All right, good morning. Good morning. I was just waiting for majority to be here. It looks like you're all here. Fantastic, or at least the majority anyways. So great to have you all here. Quick check that you can hear my audio all right. And just go ahead and use that green check like we did yesterday. And if you don't have that, I know a couple of you maybe have like an older version of Zoom or something. I'm not quite sure what the differences are there. If you don't see that, you can do like a thumbs up or something, whatever works. Or just if that's still not working, chat, it's fine too, right? Just say, hey, yeah, here, we're good to go. Okay, awesome. Good. So welcome back, day 2. Okay, so day 1 of this class is really about just getting in the right mindset and the right thought process. As we talked about that problem formulation, business problem, that kind of stuff. Those phases of the pipeline are some of the most critical that are overlooked pretty often. And I can't tell you the number of times I've gone in consulting with an organization and they've got amazingly performing models that do nothing for the company. Okay. And it's because the business alignment and what's being provided is two very different things. And it comes down to poor problem statements, right? To poor business problem statements and poor problem formulation. And like I said, poor problem formulation, it's really easy to go tackle the algorithm and stuff and go look at the data far too soon, as we talked about yesterday. That's why I stress on that one so much. Is the way you're going to solve the problem is about the business problem, right? Just kind of recapping on that one from yesterday. The way you're going to state how you're going to solve the problem, you need to look at the business problem and do it off of that, not off of the data. Okay. Now you may introduce the data at some point in that process towards the end, just to make sure that your data, you've actually got data that's going to work for you. Right. And if you don't, it may be a futile effort. You may have to stop and go, well, we don't have the right data, or maybe we solve it a little differently, but you shouldn't start with that by any means. Okay. Now at some point, if it means you don't do any predictions at all because the data just doesn't exist in the way you need it to, maybe need to go back and say, well, yeah, we're going to solve this problem a little differently with a different algorithm or something. So kind of like yesterday, we got on that kind of discussion around like binary classification as opposed to regression or something, some sort of a regression issue. I would still always be very cautious to go back, even if you have to redo that exercise because maybe the data proved that you just don't have what you need to do that. Then I would still then kind of set the data aside, go back to the business and say, okay, let's make sure we formulate this problem as a machine learning problem, identifying that we're going to solve this through these mechanisms, but still focus on that business problem, making sure that you're always hinging back to that. That's the why of why you're doing whatever you're doing at the moment. Okay. So we kind of spoke a lot about this yesterday. We didn't really get too technical. We went into SageMaker, kind of talked about SageMaker. The lab that we finished on yesterday was really a lab just to kind of walk you through the entire pipeline process. You visualized, you did some work with the data a little bit, doing some stuff with some CSVs. Within that code, you trained a model and you deployed it. Okay. Now it's pretty lightweight. There's a lot of things that you didn't do in that lab. It was meant to kind of be fairly fast in the grand scheme of things. Now it does take a while for usually for deployment to take place. And there's a big reason for that. We'll talk about that more later in the class. And I say a while, it's building a massive infrastructure behind the scenes, but it might take like 15 or so minutes for an endpoint to become live and ready to go. And there's a big reason behind what's going on in the infrastructure it's building out and stuff for you in that process. So when you say, deploy, or actually there's a fit command, PCA fit or whatever it is, depending on what algorithm you're using. So you do this fit command and it goes through and builds a bunch of infrastructure in the process. So in that regard, the deployment is usually going to take the longest. Now, once the endpoint is deployed and created, deploying a new model, a revised model to the same endpoint is actually quite fast. It's at that point, it's just swapping the models. And we'll talk a lot more about that later in class as well. But ultimately, you kind of went through that whole thing, and it just kind of gave you some insight. You didn't actually have to you didn't have to write any code. You didn't have to make any attempts at doing anything yourself. It was just run the code that's there so that you can kind of get some insight into it and some ideas into it. If you wanted to take the time, you could have gone through and really kind of inspected that code. But you can also just go ahead and run the code as well. And that's okay, because throughout the class, you're going to get a chance to get in that code quite a bit. So if you didn't really sit and inspect that code, that's perfectly fine. In fact, that's kind of the intent of that particular lab, was just to kind of give you the high level overview and not really get too involved on specific calls and whatnot, because you're going to be doing that today through Thursday. Okay. So let's kind of wrap up the problem formulation kind of phase, and then we're going to get into data collection and ingestion later this morning. But this was just kind of some stuff we didn't get to yesterday, and that's perfectly fine. Timing wise, we're doing great. But again, kind of at this phase here, we're just going to wrap this piece up, and we're going to give you a chance actually to define your problem, your business problem and problem formulation for your project here coming up. So you're going to pick a project and you're going to start with that. So there's a template, that's just a Word document. I sent it out yesterday, but I'll send it out again today in case anybody didn't get that. And we're going to have you do that small exercise. We're going to give you just a little bit of time to kind of write those things out for your project, so you always have something to kind of look back at as we've been talking about this all along. Okay. So oops, give me just a second here. All right. So first off, defining the problem. All right. So here's an example. Some products are overstocked and some are understocked. So imagine you're an e-commerce and or brick and mortar business, but you're selling products, right? And you have inventory, and this is an age-old problem with companies that sell products. Is you got to find this balance, right? If you overstock inventory, and you have inventory just sitting on the shelves for months or even years, just gathering dust, there's a couple of problems with that. One, depending on the product ages, especially like in the electronics world and stuff. That stuff is losing value just sitting on your shelf. But also, it's money that's not in the bank. It's money that's now no longer liquid, and it's sitting in the form of a product on your shelf that you can't do anything with, right? So overstocked is a problem. Understocked is lost sales, right? So somebody walks in, to a hardware store looking for some tools, and you're out of those tools. They're not going to be able to buy something else. They needed that tool. So they're going to leave and they're going to go down to your competitor and they're going to buy the tool from them. You just lost that sale. Okay. So that is money not earned when you could have. So you got to find this balance. And so this is a perfect, this is a lot of times a perfect situation for machine learning to be able to kind of find what that needs to be and kind of help you develop your orders on the, every day or every week or however you need to do that. So we got to make sure we are neither overstocked or understocked. Okay. So keep unsold inventory and missed sales low. That's the kind of general goal here. A success metric would be something like at the end of each month, you have no more than 15% unsold inventory without running out. Okay. So I want to point out here, the goal would be your business goal, right? The business, and this is again, very generically written, very short, very concise, just to kind of, or very short and quick, very vague actually, but just to kind of illustrate the point here in this context. So the business goal is hey, we got to make sure we don't have any missed sales, but we also don't have a bunch of unsold inventory. Okay. And so that's the perfect, kind of sweet spot to be in. But we got to be able to measure this. We got to know, are we being successful? And here's the thing. If we just simply measured the accurate predictions of a model, like I mentioned yesterday, we could be measuring something that's not actually helping the business. Okay, our predictions were accurate. Great. But is the business actually being successful for this? Is the model actually doing what the business needs of it? Right. And so the success metric, like in this case, is looking more at the business side, not really trying to talk about the model a whole lot, right? We're actually going to look at something on the business side and say, hey, we're meeting our business goals here. Now the model has helped us do that, versus just arbitrarily measuring the model against itself, right? So at this point, is the business being successful with this model, right? So at the end of each month, we have no more than 15% unsold inventory without running out. And so we're able to monitor that, right? We're able to measure that. And now we know the model's doing its job. Okay. All right. So each product will have its own expected inventory needs based on predicted sales figures. Okay. So we can determine the type of machine learning problem we're working with. Okay. So this is where, if we look back kind of at the pipeline, again, we have our business problem. We know that, but problem formulation is the phase that we're at now. Okay, so what kind of problem is this? What do we want it to forecast? Maybe we're predicting a value. Okay, if it's a number prediction here, maybe we're going to predict like the number of sales for that month on that product, right? And we could do something with that number. Okay, that would be a regression problem in that case, right? So in this case, we could also do binary classification problems under certain cases. So like in this example, we could take a product and we want to maybe rule out if the products are going to have less than 100 sales that month. Okay, so in all reality, if we don't sell 100, it's not even worth carrying the product perhaps. So we would rather have some missed sales with the understanding that if we go the other direction, we're going to just have inventory sitting on the shelves, and that's not worth it either. So maybe certain products we just simply decide intentionally we're not going to sell them, right? And maybe but again, that's maybe predicted on a week by week basis or a month by month basis or something like that, right? So we predict that, hey, our sales are going to be under 100. Let's scrap it. Let's scrap the product, right? Now it may not be permanent. It may just be, again, for that week or for that month, right? Just don't order it that week or just don't order it that month. Good examples, swimsuits in North Dakota in the wintertime probably aren't going to sell, but they might sell in the spring and summer, right? Winter clothes or rain clothes, things like that. In the summertime in California, it probably doesn't make a lot of sense because California, if anybody's ever lived over there, it almost never rains for like 7 or 8 months straight, usually between late spring and fall. So it wouldn't make any sense. So that's where you could do this product by product, and you could understand and make predictions that there's certain times of year or certain seasonalities or months or weeks or whatever that you're going to carry products or not carry products. So this would be a binary classification problem. Or you could also do a multi-class classification problem where we predict by month, right? So what's the best month to put a product on sale? Okay, so maybe certain products are better in certain months. So again, going back to like the swimsuit idea, right? It wouldn't make sense to sell swimsuits probably in December, okay, in a lot of parts of the world, right? A lot of parts of the world, maybe it would, year round in certain tropical areas, but areas that get lots of snow and ice and whatnot, probably not going to make sense, right? But also, here's the thing we have to kind of think about. We want to frame the simplest solution. Okay, and I do want to point out this couple of slides makes it sound like we have to choose one or the other. You may want to create multiple models. Like I might create one model that simply says, hey, if it's less than 100 sales, scrap the product. But if it's got more than 100 sales, we're going to run it through another model to understand its demand and understand, what number we need to order. How many products do we need to order, right? What's our inventory need to look like? So we need to make sure that that we don't lose important information, because like if you look at the simpler one here, the less than 100 sales is just a simple binary classification problem. Okay. Now, somebody might say, well, but you're predicting numbers, and that is true, sort of. Okay, here's the thing: there will be numbers in all cases. All machine learning problems are numbers. Okay, we're going to convert categories to numbers. We're going to put everything. An algorithm doesn't know what a word is. Okay. When we talk about natural language processing and things, that's a little different discussion. But we're talking about like a category. So if I go back here, the category November is not going to be called November in the algorithm. We're going to give it a number or something. Okay, we're going to talk about that. We'll probably do one hot encoding or something. But it won't be November. It'll be a number because algorithms are mathematical equations. Okay. So yes, numbers are involved there, but the output is whatever we're predicting. Okay. We are predicting a yes or a no in that right example. Okay. We are still looking for the idea that the sales are less than 100, but we're not predicting the actual value. We're predicting that it won't be over 100. And so we're not predicting an exact number. So that's why we're going to lose forecasting and sales information with that particular problem, because it's about what we predict. Okay, the algorithm we choose here tells us the output, and the inputs, and the algorithm is going to use numbers. It's going to make calculations. Okay, but the final prediction is what we're talking about. The final prediction. Yes or no is a binary classification problem. 0 or a 1 is what we're going to predict. Okay. And the 0 or 1 comes from, in this case, is the sales, is it above or below that 100 sales mark? That's all we're caring about. Is it going to be more or less than 100 sales? And then the one on the left is just a number that we're going to forecast. So in that case, that might be a regression problem, because we're actually forecasting, we're actually predicting the number. So I want to make sure we're kind of understanding a bit more about what we talked about yesterday on this, that it's about what you're predicting. So a regression problem is about predicting a number. Now, I know there's some variations of that where you could predict a number of 0 or 1, and you could argue it's not technically a binary classification problem. It's a regression problem, but there's some more advanced topics you could get into, get a little confusing. But a binary classification is it's one or the other, whereas regression would be predicting a number. Okay. And so normally in a lot of regression problems, predicting an actual value, not just a 0 or a 1. Okay. So that's kind of the general kind of idea here, is we want to try and not lose important information. So the idea of yes or no, it's totally abstracted, right? At that point, the actual numbers are gone. We don't see the actual forecasted sales. It might be 1,000 sales. It might be 10,000 sales. It might be 10. The thing is, all I know is that it's a yes or a no in this model. Okay, on the one on the right, one on the left. Now we actually have a value. Helps us manage that supply and inventory. Okay, so kind of find the simplest solution to your problem, but without losing important information. That's the big message. Okay, all right. So then we get into our data. Okay, then we get into our data. So like I said, we try and say, here's how we're going to try and solve the problem. Now let's go look at our data, and do we have sufficient data? Is it appropriate for what we're trying to do? How much data do you have? Where is it? Do you have access to it? All right, all very important questions. Okay, do you have the data that you need to try and address the particular problem? And is it representative? Now, representative, what do we mean by that? That is actually a really important part here. And I want to look at the title of this slide, Get a Domain Expert. It's also a big problem. A lot of machine learning people say, I know machine learning, and they try and tackle all problems themselves. Okay. This is a mistake. You can't do everything yourself. You can't know everything yourself. Do you know the business? Do you know the business, right? This might be where you need to get somebody in that understands the business a bit more and can help drive understanding of if that data is actually representative. Okay. Now, representative means, does it actually represent the business? Is there stuff missing? Does it look balanced? Right. Now, here's something else about being representative. Let's say we're forecasting fraud. Okay, we're trying to forecast fraud, and let's just say it's a binary classification problem. Fraud, not fraud. Okay, yes or no. All right. So we're not giving it like a fraud score or something like that. We're just saying we believe this is fraud. Okay. Just to simplify the discussion, just kind of hang with me for a second here. If I have 1,000 records that I am providing to the machine learning environment, right, to the training environment, I got 1,000 records, and 5 of them are fraud, or 2 of them are fraud, or 10 of them are fraud. It's not enough for it to really see the patterns in what is fraud. We're trying to predict fraud, yet we have nowhere near enough records to actually teach it what fraud is. We can teach it what fraud is not, but we're not going to be able to teach it what fraud is. And so you may say, well, it's representative to real life. Fraud doesn't happen on every other transaction. And that is true. But in the case of training, we need to think of it like if you're training a human being to detect fraud. Do you think if I don't know if any of you here have flown in the last 10 years, but you fly on an airplane, you go through security, and your bag goes through a scanner. The amount of bags that go through the scanner that are perfectly fine versus those that actually have weapons and bombs and other things in the bags is probably very, very small. But do you think when they train those people when they're scanning bags, do you think they train them on all good bags, or do you think they train them with images and things of stuff that is problematic? And of course, they're going to inject a whole lot more in their training to show them what to look for, right? Well, same thing has to happen to the computer. You have to show it enough. So it's not about waiting at that point. At that point, representative does not mean representative in terms of, well, it's only fraud 5% of the time, so we're only going to have 5% of the data be fraud. That's not the kind of representative we're talking about. In fact, you'd be best off having 50-50 if you could. If you could show it when half the time it's fraud, half the time it's not fraud. If you could have 1,000 records and 500 of them are fraud, now it's going to make the distinction. It's going to learn a lot better about how to make that distinction. That's called class imbalance or class balance, right? So class imbalance would be if I only have 5 records out of 1,000 that are fraud, that's class imbalance. And what you've just taught it is that it can be accurate if it just never predicts fraud. And going back to that example I mentioned yesterday, in that example, you teach it, hey, I've got 1,000 records and 5 of them are fraud. Now in that case, you just taught it that all it has to ever do is predict that it's not fraud, because it will be right 90 somewhat, whatever the math works out there, 99% of the time or whatever, by just simply saying it's not fraud. It'll get those fraudulent ones wrong, but because it's so small, it'll look like it's right most of the time. Okay. So when we say as your data representative, we're talking about columns or features of information. We're not talking about weighting there. We're not talking about the record counts, because those should be as balanced as possible. Okay. We're talking about, is the data representative? Do we actually show values and show information there that actually represents the environment we're trying to go after? Okay. Are the values that we're using, do they make sense? Are they good values? So just as an example, on finance, if you are looking at like profit versus revenue, right? Those are so different. And I may not care about revenue a whole lot. If my profits are in the negative, I could have really high revenue and have lost money, right? Because if it costs me $100,000 to make $900,000 or $90,000, I've just lost $10,000, right? So if it costs me more to make the money than I got, I don't care that you made $100,000 at that point, or 90,000. You get the idea. So I don't really care that you've made so much. I care what you actually profited, maybe. So is it representative? Well, somebody's going to look at that and go, well, you're looking at revenue. We should be looking at profits. And a domain expert might be able to spot some of those things. And that's a really simple example, but there's much more advanced examples than that, where somebody in a domain is hopefully going to be able to spot some of that stuff that maybe just the data scientist doesn't necessarily understand the industry well enough to be able to spot some of those nuances, right? Okay. And then the quality of your data. Is there missing data, right? As an example. So here we've got some stuff where we just don't know. So if it's missing data, why is it missing? So these are big questions we need to ask. We need to say, well, first off, why is it missing? Maybe there's a bug in the software. Maybe there's a field that should be required that's optional. Maybe there's something we can do on the back end to start cleaning that up moving forward. But also the fact of the matter is this is blank data. So can we get it? And if not, what are we going to do with it? Okay. And we're going to help answer some of those questions as we move forward. So also labels that you already have, already known label. Again, a label is the thing we're going to predict that we already have an answer to. Okay. So we have this data and we've already been able to say, yeah, this is fraud or this is not fraud. Okay. We've already identified that after the fact. And so when we go to train, we'll train it with these labels. Right? That's that whole supervised learning. We're going to say, hey, look, when a record looks like this, it's not fraud. But when it looks like this, it was. And then we got another one. And, yes, no, and we'll kind of look at those. And it's going to start identifying patterns in the data But again, what is that pattern in the data? It's not just some random pattern in the data. It's that when I apply an algorithm against this column, excuse me, I'm sorry, against this row, I apply an algorithm against it with certain weights. And then I apply the algorithm again with different weights, and I'll do it again with different weights and again with different weights and keep doing that. What does this do to the outcome? Okay. And it's going to keep doing that to kind of understand patterns in what makes non-fraudulent transactions different than fraudulent transactions. Okay. And so it's not just, oh, it's over a certain value. That would be a hard rule, right? So a lot of people look at this and they go, oh, maybe it's basically just coming up with a rule that's like, oh, if it's over $700, it's fraud, or something like that. And that's not what it's doing. Okay. It's not looking at patterns like that. It's actually an algorithm, and it's looking at the results of the algorithm based on the weights that are provided, and kind of understands that it's there's patterns that emerge on what happens to these through the algorithm. Okay. And it's about the combination of everything that's going on. All right.
So what if you had a scenario where the fraud is actually if the number is above this number, like they're never supposed to charge that amount? You'd put the weight in there? That's how the algorithm would know if that's actually fraud? Because that's how you know it's fraud, right?
No. So that's the thing, is if it's just over a certain value, that's not really a signal of fraud. It could be a part of the picture, but there's probably more to the picture than just over some value. If it's just over some value, that's not a machine learning problem even. That's just a classical programming approach where we say anything over 800, let's flag it as fraud.
Okay.
Right. That's not a machine learning problem. So the way this works is we're going to say, here's the data. Here's the data, right? Submit all of this to an algorithm. We've already told it. We already know the answer. Okay. Now this one we don't know. Okay. But what's going to happen is going to take the algorithm. Uh-oh. Hold on a second. I have a technical issue. I don't know if you can you all hear me still?
Yeah, but your arrows, like, we can't really see your screen really.
Okay. Yeah. The screen just had some issues. Okay. Hold on a second here. Let me see if I can fix that. There we go. PowerPoint was not happy. All right. Wasn't sure if it was Zoom or PowerPoint. All right. I think we're good. Maybe. Okay. Maybe. Hold on a second. It's still. Let me close this out. 1 second. I'm just going to reshare it. I think it was just a problem with the share. Okay. So I'm just going to reshare this, just kind of reset it real quick here. PowerPoint did not like that. Okay. All right, we should be good. You can see my screen okay now? Quick check in here.
Yeah.
Okay, awesome. All right. So so the idea here is that, it looks at this. Whoops. I'm going to turn drawing back on. Okay. All right. So it looks at, this row, and it applies a column, it applies an algorithm to it, and it just gets some value behind the scenes, some mathematical value that comes out that it applies to all of these, all of the values in the column, in the row. Okay. And it gets some answer. And then it changes the weight. It changes the weight. We don't. It changes the weight to that algorithm, and it runs it again, and it gets another value. And it runs it again, it gets another value. But it's not doing it by itself. It's doing it against all of the rows and trying to see what happens to that final value, and if there's some correlation between the fact that this is a no and that is a yes. And it starts identifying, some sort of pattern that comes out in those numbers. We go, oh, when the weight changes to this, all fraudulent activities seem to have a particular value range or something. Okay, I'm just kind of just generally speaking, because it all depends on the algorithm. Every algorithm is handled a little bit differently, but basically the way the algorithm works during the training process is it starts to identify a pattern. But that pattern, again, is not a pattern in the data itself. It's a pattern of the results of the algorithm run against the row. And so it starts realizing, oh, you know what? I'm just giving you a total kind of abstract, very high level answer here is let's just say every time it's a no, that the mathematical equation ends up under or I should do something like ends up like this, less than 100, and then every time it's a yes, it seems like the it's like that. Okay, and so it tries to maybe identify that there's some sort of value here that maybe now it says, well, gosh, anytime the resulting value looks like that, it's probably not fraud, or probably is fraud. And so now it comes down to one it doesn't know when you go to actually do a prediction. And if the answer, of the algorithm is less than 100, right, then at that point it's going to equal no. Okay. Again, I'm just kind of overly simplifying the algorithm and what it's doing behind the scenes. It's supposed to be 100. Okay. So behind the scenes, it's kind of looking for patterns of the result of the algorithm, not just, every time some value is over some threshold. Okay. It's not that kind of pattern recognition. People are thinking, when you say the word, when people say it's looking for a pattern in our data, a lot of people think that it's literally looking for a pattern of, every time the prediction is over a certain value that it's fraud, and that would be a terrible way to do fraudulent activity identification, wouldn't it? If all we did is look for any value that was over some threshold, that would be a classical programming approach, and it would be wrong most of the time. Okay. I have particular credit cards that I don't use every day, that I only use if I'm going to do a larger transaction. So all of a sudden I haven't used it in months, and I go buy something for $1,000 on it. And that would just trigger fraud every single time. All right. Or in all reality, what if fraud is most common under $25? I mean, that's really common. I've had a couple of situations, actually somewhat recently. I had my credit card company contact me, and there was a transaction for $9.99 that was definitely not mine, and it triggered their fraudulent detection. Obviously some good machine learning predictions, and it was in fact wrong. And it was because they had location data and other things. There was a collection of factors, right? It wasn't just one factor. It was a collection of factors. So you have to look at all of the features. Okay. You can't just look at some value. It's about all of these things together. Okay. Maybe certain days fraud is more common than others. I don't know. Maybe certain locations fraud is more common than others, or old programming approaches, old classical programming approaches used to be for credit cards that if it's outside of your purchase area, it would flag something. Well, a lot more people travel, even today with COVID and stuff. There's still a lot of people traveling and doing other things, and you go run your credit card in another state. It shouldn't just suddenly deactivate the card because they think it's fraud. It should be smarter than that. So like I have a credit card company that I work with that does a lot of business transactions, and it's smart enough to know that if I run my credit card here in Texas where I'm at and I go fly somewhere, did the transaction happen 2 minutes later in another state, or did it happen with enough reasonable time that I could have traveled there? And maybe it even has flight information built into their data. Maybe they already know that it's likely I took a particular flight because I ran my credit card in the Dallas airport, and then I ran my credit card again in the Chicago airport at O'Hare or something. And they see the flight data and they go, wow, he was probably on that flight. That's probably a legitimate transaction, right? Not just that it's in another state. Okay. But the only way to identify that is not just one factor. There's a whole bunch of factors, hence the reason the need for an algorithm, not just some threshold over some value in some column. Okay. So it's about taking all of these values, running them through an algorithm, and having some arbitrary number. But it's about that then compared to the next row, compared to the next row, compared to the next row. And it's going to learn differences that emerge between the no's and the yeses. And it's going to start to say, hey, when I make this weight change here, we were accurate in what we do. Okay. And so then you could take these answers away and it would be able to predict those values. Okay. So that's the general principle for some of you that are newer to this. And again, I'm overly simplifying it. I know some of you that are a lot more advanced on this and are very familiar with the algorithms and really experienced here. there's flaws in my analogies, my examples. I understand. I'm just trying to keep it kind of basic for now to kind of help illustrate what's going on behind the scenes. Okay. So autonomous driving, a car that is driving on the road has a lot of labels. It needs to know what the signs are, what the road is, what people are, and kind of be able to identify a lot of those different things. Okay. And then also, don't forget, we can use SageMaker Ground Truth to generate that label data. So if we have data that is not yet labeled and we want to use that for training an algorithm that needs labeled data for supervised learning, we could have a team label it for us, right? And we kind of talked about that one pretty extensively yesterday. Okay, so identifying success. We're going to know that we're doing it right through model performance metrics and business goal metrics. We have both. Okay. And so model performance metrics, these are basically used during the evaluation of the ML pipeline. We're actually testing and evaluating the model. Okay. And this is in terms of accuracy. How accurate is our model predicting our making our inferences? Okay. So making our predictions. So again, the way we can identify this is I have a whole bunch of historical data I can strip the answers from, submit it to the system, and maybe it makes those predictions about fraud, and it says yes, no, yes, no, yes, no, but I already know the answers, and I compare the predictions with actual, and I'm going to know how accurate I was. And then as we make changes to our model, did the accuracy percentage go up or down? And then I know if my changes are actually getting better or worse, right? And so I'm going to do that through the building and evaluation testing process here. But eventually, I don't care if my model is super accurate if it's not meeting my business goals. So again, I need to have this match my business goals as well. So in this example, the model needs to accurately identify at least 75% of the fraudulent transactions in the test data set. That would be model performance metrics to say, okay, our model is performing the way we want it to. Okay. But the business goal in this case, this is after the model's been deployed. Now we got to make sure that it's actually performing in the real world. Okay. And this is, again, one of those things that a lot of people miss. They're not monitoring this because they're looking at model performance metrics saying, hey, we're doing amazing. We're doing amazing. Look at us, right? Meanwhile, the business is not getting any benefit from it. Or maybe we're even making it worse for all we know because we're predicting the wrong thing and it's not helping us and it's the wrong measurement, right? So how well is the model actually performing in the real world? And we can help identify inappropriate model performance metrics. So again, this is where if the business goals are not being met, or maybe we're even going the wrong direction in the business, we can look back and go, well, I don't care if the accuracy of the model is 99%. It's still inappropriate for what we're trying to do. Okay. So in this example, 6 months after the model's been deployed, we should have at least 50% fewer customers who cancel their cards due to fraudulent transactions. Okay. And this is a big one in the fraudulent, financial space. Like I said, I've done a lot with business over the years and various credit cards I've had, and I've learned which credit cards I can use traveling, which ones I can't. I have canceled credit cards because of this for two reasons. I've canceled them where they did a terrible job at identifying fraud, and I said, I can't keep up with this. We got to keep disputing transactions. Cancel the card. You're doing a terrible job. Meanwhile, the flip side of it, though, if I have cards that instantly deactivate when I use them out of state, that's because they're using classical programming approaches most likely, or just really poor ML models. And they go, oh, you used your credit card out of state and you didn't tell us. I had a card that would do that. As soon as I swiped the credit card out of state, it would be deactivated. They would contact me and they would say, hey, is this a legitimate transaction? I'd say yes. And then maybe they would reactivate the card depending on how much time I took to get back to them. But meanwhile, my card was deactivated and I had to contact them and we had to go through this whole process. And they said, well, it's really easy. Just contact us. They wanted me to tell them every time I was going to travel somewhere, right? Well, if you're somebody that never travels, that's probably not a big deal. But if you're in 3 different states in the same week, good luck trying to keep up with that. Call my credit card company every single time I'm going to fly somewhere. That there's no way. And so I had to cancel cards because they kept deactivating my card. Now, some people would say, wouldn't you rather them err on the side of being careful and assuming it's fraud than not? No, I wouldn't, because if I get somewhere and I can't use my credit card, and I relied on that to rent my car, I relied on that to get my hotel room and everything, it is a real problem. Okay. And so I would rather them be accurate in both contexts. I can't just say error on the side of fraud. That's not good either. So I've had companies that they've lost my business for both reasons. And so you can see why, I mean, this is a tricky, fraud is a tricky one, because you want to predict that it's actually fraud as careful and as accurately as possible. You can't just error on the side of fraud, because then people's cards are problematic, right? And all these completely legitimate transactions are being flagged when they shouldn't be. And people are getting frustrated, and they're not going to stick with the company. Okay. So it needs to be a balance, and we got to be as accurate as possible in both contexts. Okay.
Okay,
Yeah.
Grant, quick question. Can you go back to previous slide? Who decide this statement? At least 50% customers who cancel their car. Is that a business decide that, or a model developer will this?
Oh, great question. No, this is the business. Yeah, the business goal metrics, and we should be building our model to meet this requirement, right? So the model performance metrics are also defined by the business too. I mean, a model, a machine learning team, whatever that might be, I mean, they can be labeled all kinds of things or called all kinds of things, shouldn't come up with this number either. I mean, how do we know what is good enough for the business? We shouldn't make it in a vacuum. Okay. Both of these should be the business should be heavily involved. Okay. Now the ML team will have influence a lot more on the model performance metrics, and is going to be the one actually performing these measurements. But how do we know what's good here? Right? We shouldn't make this decision in a vacuum, because we could try and do that, and we could say, well, it needs to be at least 75%, but that means we're doing it in a complete vacuum. If we are going to do that in a vacuum, it needs to be with the understanding that it has to meet business goal metrics. So if we're, I mean, I think 75% here is really low, to be honest, right? That's only 3/4. It means that 25% of the time we're wrong, and we could have a problem, right? So so who sets that line? Who sets that line in that measurement? And that's a big political discussion, right? It's not just one team or one person shouldn't make up this number. It should be a joint effort. Now, it shouldn't just be the business either. Okay. It should be a combination of both. But the business goal metrics is really just the business, because this is why the business has come to us and said, we need this prediction. This is why. So we've been hired to do a job, and this is the measurement of the business to say whether or not we're succeeding in our job. Okay. So this one is about the results of the success of the model. Okay. And that the business is actually getting what they wanted out of it. Okay. Yes, 100%, Anna. Yeah. The definition of success during the problem definition to be related to the goal metrics, business goal, 100%. Yes, 100%. And that's why we're in that. I mean, this whole section, this whole slide deck that we're looking at right here is all part of, problem formulation. Okay. So we're building that problem right now. We haven't started training at all. Okay. In fact, I want to point out, and that's a really good point, Anna, is that these metrics, these things should be defined before we even try and train, before we should even try and do any of the work. We should know what we consider success before we even start building something. Okay. This is not unusual, right? I mean, any other project out there, any other IT project, programming project, heck, even non-technical projects, somebody's building a bridge or whatever, any project out there, you should define success before you even start the project, right? And that's the same thing here. So the definition of success for this should be related to the business goal metrics, 100% accurate, 100% yes. Okay. So that's, we're just saying, look, both of these are metrics that we need to define, though. They're both metrics that we need to define. We need to define what we consider a good model, and we need to consider what is a good business goal and what are the metrics we're going to use to monitor both of these. Okay. The first one, model performance metrics, is only performed during the training process. The training process. Well, train and then test. We test our training. It's all kind of part of the same activity. Okay. our model is not successful until we hit this threshold. Okay. And it's in terms of, it's not even an acceptable model to put into production at all until we at least have this threshold. Okay. Then the business goal metrics actually are used to measure success after it's been deployed. And now we're going to say, is this thing actually helping the business like we thought it would? Okay. And both of these should be defined before we even start any coding, before we start anything with data, start manipulating anything, start doing anything at all. Okay. All right. Wonderful. Wonderful. Okay. So, so that is problem, it's all about problem formulation. So here's an exercise that we're going to do. This one's pretty short and it's kind of, again, fairly non-technical in the sense that we're not going to work with data yet, but as soon as we're done with some of these exercises, we're going to shift over and start working with data. Okay. This says estimated completion time 30 minutes. I'm actually only going to give you like 10 or 15 minutes, only because you could spend unlimited amounts of time on this and you'll have the document. You can always revise it on your own, outside of class or beyond class. You could always enhance this thought. I just want to get you thinking, give you a chance to apply these mindsets to this. And so these exercises are quite good. So there's going to be different business scenarios, and and these are in the in the documents I'm going to give you. They're just Word documents, and so you can actually go through and write your own thoughts and stuff into it and save it locally. You don't need to turn it in. Nobody else is going to really see it. But basically, we're going to have a couple different business scenarios we are going to provide you, and you're going to determine if and why ML is appropriate. So some problems ML isn't even appropriate. Okay, we're going to say, nope, that's not an ML problem. Just solve it through classical approaches. And then, yes, it is an ML problem. So if it is an ML problem, what is the business problem, the success metrics, and the desired output? Okay, and again, we're not looking at data yet. We're just saying, here's what we expect from this before we go to the next step. Okay. And then what type of ML problem? Is it supervised, unsupervised, regression, that kind of stuff? Reinforcement learning, any of that kind of stuff. And then again, the last one is the data appropriate? Now, in the documents we're going to give you, we're not looking at the exact rows and columns. Where the data is going to be generally stated, and so you say, well, I think we've got the appropriate data to do this, right? And then we actually start diving into the rows and columns. But what we decide if the data is appropriate by just simply starting with the concepts of, we have this type of data, or we have data from this system. Do you think it would be appropriate, right? So kind of high level. And then we're going to go, in real life, we would then take it to the next step. After that, we would start looking at actual data and start diving in, right? But we got to know what success is so that we can always kind of go back to our why, So let me go ahead and pull this up here. And there's just some documents here that I want you to use. So problem. Okay, so this is the problem formulation exercise. Okay, so let's go ahead, and there's this first one, problem formulation exercise. Okay. X, good. Okay, so that, let me know if that link has a problem. I may have had an issue with that, but we'll see. And then the solution. There's also a separate document that's got solutions written in it. Okay. And this way, if you kind of get stuck, you're not quite sure, what you think. And so the solutions are just a solution. Okay. So the there's more than one solution to kind of any problem, right? So I want to point out that the solutions are just a solution, not necessarily the solution. Your solution might be perfectly fine as well. So you can compare maybe with what you do with the solutions provided. But let's just go ahead and take like 15 minutes or so, have you open up the problem formulation exercise document. Let me go ahead and open it real quick. I'll share it on my screen just so you can kind of see what we're working with here. And I'm going to put these documents in your WebAge portal just so you've got a reference to them, and they'll be there for the coming months. If you want to go back, and if you lose them or whatever, you can re-download them. So give me a second here. I'm opening up the document right now. So I just want to show you real quick, and then we'll set you loose on your own for a few minutes. Again, nothing too crazy advanced here. We're not trying to expect you to solve world hunger. Okay. If I can get this to show up on my screen properly, there we go. This might be a little hard in the screen share. Let me zoom in. Okay. So basically, and you can go do this on your own. Go through each one of these. Like I said, let's kind of go fairly swiftly through it. I don't want you spending too much time on this, but I think you can obviously spend as much time as you wanted on this on your own time beyond. But read through this. Again, these are kind of the 4 things we're trying to answer. Is the machine learning appropriate for this problem? Why or why not? So make a little note why it is or why it isn't. What is the ML problem if there is one? Again, is it supervised, unsupervised, that kind of stuff? And then what would a success metric look like? What kind of ML problem is it? I'm sorry, that's supervised, unsupervised, that kind of stuff. And then is the data appropriate? And so you read through this scenario, and the first one is done for you. Okay, the first one's done for you, so you can kind of get an idea of what we're looking for. And again, you're not going to turn this in. So if you don't type this in full, right away, right now, that's fine. Just kind of be thinking about it at the very least. But if you want to type it in, be as as robust as you want. But I'm not going to give you crazy amounts of time for this. Okay, it's about getting the thought juices going. We have more things to cover this morning, so I'm going to kind of keep this at a fairly minimal time for you. And so now 2, 3, and 4 are for you to fill out. Okay, so you can kind of just get your thought process on this going. And then again, the solution is provided in that other link I gave you. And you can kind of cross compare and see what the solution provided. Now, again, put in the whys and things in here, just going to get your own thoughts on paper, if you will. Right. But again, this is just for you to kind of get thinking on this front a little bit differently maybe than you have been historically done, especially if you've got experience in this realm. Maybe this is new to you, and or you just you've never really stopped back and thought, hey, maybe we're not spending enough time on this. This is not just busy work. Okay, this is really important stuff that, like I said, I've seen many businesses fall flat, many hundreds and hundreds of hours just completely blown because this step wasn't given the time it needs to be given. Okay, so that's why we're trying to really kind of hone this in so that we know what success looks like. Okay, it's really important. And again, just don't worry about the data yet. Okay, we're looking at the business problem. We're making some statements around it, and we're going to specify some success criteria, right? And roll with it. Okay, so I'm going to give you a few minutes on this. Like I said, nothing too crazy. We're at 9:27 right now, Eastern time. Let's check in at about let's do like 9:50. Okay, so you get about 23 minutes or so. Okay, 9:50, 9:50. We'll check back in. Just have some fun with this. Be relaxed. It's nothing too crazy. Like I said, you're not turning it in or anything. So it's for you, okay? And you don't just skip it. Some people go, well, this is just busy work, and they're not going to do it. Trust me, it's worth the thought process, okay? You really should be doing this on all of your ML projects, not just this little exercise, okay? So go ahead and jump into it. We'll see you back here at 9:50, 9:50 Eastern time. All right. Have a good little exercise here. All right. Go ahead and use that green check or thumbs up, whatever you feel like. Let me know you can hear me okay. All right. Good. All right. So you may have more you want to do on that. That's totally up to you. You have that document. Like I said, you're not turning it in or anything like that. Just kind of wanted to get the thought process rolling. And like I said, the solution is just a solution, and there's explanation kind of in there as to why, why it was chosen and whatnot. So that's kind of the thing we're looking for from you in this case, that you should be looking for yourself, I should say, is, explanation. It's so that you can turn back to this at any point in time, or somebody else could even turn back to it. If you use these documents, these are actually really good template documents. For moving forward, I'm going to give you some template documents for your project that we're going to get ready to do and get started. And they're really good for just kind of any ML problem you encounter. You should be using these types of things. You should be writing this stuff out, and it's not just busy work. It's really intentional, so that you can always look back at it and say, we're on track. We're going the right direction here. We have the right metrics in place. That you've spent the time and energy to work with the business on this to make sure you are achieving the goals you're trying to achieve. And you get better and better with this with time. But really good, clean, concise statements, as we talked about yesterday, are really crucial here, because others are going to be able to look at that too. Everybody can kind of be on the same page. And if people don't agree with it, then we can discuss it and clarify it, as opposed to just having a faulty ML model where we go, well, this is what that said, so that's what I produced, and the business meanwhile is suffering from it. So we need to all be on the same page. Okay. And so these are really helpful kind of just thought work exercises. One more that we're going to do, and I'm also going to throw a break in the mix. And then we'll be done with kind of this more administrative kind of stuff and start getting into actual, the data science, machine learning exercises, starting with the data, right? So, but for now, let's kind of wrap this up by starting with your project. Okay. So what we're going to do next is, like I said, I'll couple this with a break, but you're going to work on a student project document. So you're going to do the same thing you just did, but for your own project now. So what we're going to do is you're going to open this document. I'm going to give you the link for it again. But this is your project template. Okay. And there's 3 projects involved here: flight delays project, the recommendations engine, and the fraud detection. And it kind of recaps what each one of these are. And, read through all of this. You're not going to be asked to really share all this stuff out. Again, it's just for you. But really, this is great, again, to kind of help you apply this stuff in your own work as you're coming across these problems. Okay. And so what we're going to do is we're going to do this step 1 here. Okay. We're going to do step 1. So you're going to select the project, and you're going to write in here, recommendations or something, or flight delays or whatever you're doing. Okay. Make sure you select your project by just kind of writing it in there, and then answer these questions. Okay. So you're going to fill this out, and then moving forward, I'm not going to keep bringing this document up to you. You have the document, but moving forward, as we go through the different phases of the pipeline, it is helpful if you come into this document and take notes. Okay. And so, like, when we get into the data exploration and data pre-processing phase, ask, state some stuff here, write some things in here about your assumptions about the data. Ultimately, what does it tell us about the data? Kind of this just gets you thinking. These are great exercises. Again, it's not just busy work. It's actually just to kind of get your brain in the right mode. A lot of people, like I said, are really talented, very brilliant people, but they're not thinking in the big picture context, and they're making models that perform well, but the business isn't seeing any benefit from it. And it's usually stems from, again, not enough thought work going into this side of it, right? Not just moving forward. I mean, it's too easy to just step on the gas, get some data, start manipulating it, shove it into a model, a model training exercise. You train, you produce, you say, look, I've got my metrics, or I'm highly accurate. We're done, right? But we really shouldn't be doing that. In fact, there's actually been a lot of studies done around this stuff, and a lot of work done around this, where some might actually say, I've heard this a couple of times, that this first step here, this problem formulation and getting started, with an experienced team that does this stuff all the time, this should be like a 3 or 4 week project. Just, I mean, this step alone, 3 or 4 weeks should really be spent on really honing this in. That's a long time, right? A less experienced team might take 6 weeks, right? That's, again, really long time. And why is that? Because, we really need to kind of go back and forth with the business to really frame the problem. Now, again, that's loosely stated, and I think those numbers can be kind of inflated. It depends on the problem we're talking about, right? How simple is it? Is it really concise and really specific, or is it a much bigger problem that we're trying to solve? If it's kind of like an everyday thing, or is it something monumental to the business, right? I think those things do weigh into that. And I think that's where those numbers can be kind of weird. Is obviously I want to spend 4 to 6 weeks on this. If this is an earth shattering, completely change our business kind of model, right? But on the flip side of it, if it's something that's just kind of going to help us with maybe some basic marketing or something, maybe we don't need to spend quite the effort on it, right? Because we can trial and error with marketing. If we don't get it quite right, it's not going to break the business, So it depends on the model. Or let's say, what if the model is being applied to airplanes, and it's going to affect people's lives if the model doesn't work right? Does anybody remember the Boeing Max? The 737 Max, I think it was. It was grounded for a really long time. I think it's flying again now, but it was grounded for over, I think it was like almost 2 years, a year and a half or something like that, 2 years. It was a software problem and actually a machine learning problem. So what happened was ultimately, based on some sensors and some other things, the plane, the way it's actually made, I think it's kind of crazy. The way the plane is actually made, the wings are set farther back than they're supposed to be, and it technically shouldn't fly. If it didn't have software, it wouldn't fly. And I think that's, again, I think the reliance on, there's been too many movies made about the reliance of technology, right? But the plane, that Max plane can't fly aerodynamically. It can't fly without software, because the software actually always kind of keeps the nose up. It actually compensates and actually forces it. But there's these sensors that went bad on it, and it was actually forcing the plane down. So as the pilot was trying to fight the system, it would actually force it down even harder. And it was just literally flying the plane into the ground. And that's what caused those 2 major accidents that we had. So obviously, if you have an ML problem that is life and death, you probably should spend a bit more time on this phase. Okay. Right. I hope that's kind of obvious. And then on the flip side of it, maybe it's an ML problem that's, like I said, some marketing campaign, and if we don't get it quite right, we'll learn from it and we can do the next, right? So I would argue that, I probably wouldn't want to spend 6 weeks on a basic marketing campaign, because maybe the marketing campaign is past now, and now different opportunities emerged. So, when I say those timeframes, I just want you to understand that, it's all about the bigger picture there and how much time and effort we really want to put into this. Point is, we're giving you 20, 30 minutes in class. This is not a 20, 30-minute exercise. This is at least a few days minimum, okay, to really put the thought work into it, get teams together, really kind of brainstorm this to make sure that we're truly successful here, okay? But it's not always going to be 4 to 6 weeks, but in really, complex problems to solve, and really, life and death, we really need to be very specific and take good time on this, okay? All right, but here in class, we're going to have you do just this step 1 right now. And then we're not going to make time to do any of these others in class. Okay. These are for you to kind of continue on as you're going. If you wish to do that, I would encourage it, but not a requirement. Okay. We're going to give you time right now, though, to frame this, because, again, like I said, you got to make sure you're in the right mindset before you even start building stuff. So we're going to answer these 6 questions. You're going to do those yourselves. The template for this, let me give you the link to it. Student project template here. Okay. And then there's going to be an example template project as well. So just to kind of give you, again, this is a sample or a solution, if you will. You can take a look at that completed one as kind of a reference to kind of get an idea of what we're looking for, right? To kind of give you, again, the right kind of context and kind of give you a broad understanding of what we're doing. Okay. So both of those links there, and you can open those up. We're going to take a little bit of time. We're going to take about 20 minutes to do this, and then we're also going to throw a 10-minute break in there. Okay, so take a 10-minute break now, or midway through, or at the end, or whatever. But we're going to take a total of about half an hour, but only allocate about 20 minutes to writing this stuff for yourself, and then we'll reconvene class in 30 minutes from now. Okay, so we are at 10:01 Eastern time, so 10:30. Okay. Ish, 10:31 technically, but all right. So we'll see you back here around that time, 10:30 Eastern. Take 20 minutes for the project here, project template, and pick a project. Okay, this is now your chance to just kind of pick the project and start running with it. And it really doesn't matter which one you choose. They're different types of problems, but at the end of the day, the work is already kind of laid out for you as far as what you need to do for it. So it's not completely up to you. You know, we're kind of giving you a path. So all of the projects we've already got solutions to and everything. So we're going to kind of walk you through that path. Okay. But you're going to create code for these as we go. Let's go ahead and reconvene in a half an hour. All right. So let me know if you need anything at all. I'm here for you. All right. Otherwise, we'll see you back here at about 10:31 or so. All right.
Hey Ryan, can I ask you a question about the problem formulation exercise that we did just before this? If you're there.
All right, welcome back. Go ahead and use that check or thumbs up, whatever you want to do to let me know you're back. Ready to go. You can hear me okay. All that. And like I said before, you can go ahead and, spend as much time on this as you want on your own time. You've got the document. You can expand on it, put a lot more thought work into it as you want, as little or as much as you want, right? Okay, good. And if you're back, go ahead and check that. I'm actually only seeing about a third or maybe half mark. So just if you can let me know you're back, that'd be great. There we go. Just a few more. Again, if you're back from break, you can hear me okay. Go ahead and let me know by signaling with that check or thumbs up, whatever symbol you want to use there. All right, that's looking a little better. Okay, good. I'll go ahead and put put all that down. So there was a question that was brought to me privately. I just wanted to bring it up. It was about the formulation exercise that we did before this. So let me just share my screen here. So this was the first document of the two that we just filled out. So in step 2, or the second scenario, I should say, the scenario was, the business analyst of the social media company focuses on streaming. Streamers use a combination of hashtags and predefined categories to discover your platforms, to be discoverable by your platform's consumers. Okay, so that first statement throws a lot of people off. Is we're saying, hey, there's predefined categories and hashtags, and so wouldn't this be a multi-class classification problem? But if you really kind of keep reading and don't skim it too quickly, you start realizing the whole point here is that we don't believe the categories we currently have defined are accurate or good. Okay, so what we want to do is, in this problem, in a nutshell, I'm kind of just summarizing. If you kind of understand that, if you read it carefully, you kind of start to infer that the business wants to ultimately see if there's maybe categories we hadn't thought of, right? And so instead of, we're not classifying things into an existing category. That's not the objective or task with this one. With this one, we're trying to see if there's categories that maybe should exist that don't, right? So what we're going to do is we're going to actually take our data and send it through an unsupervised algorithm and let it group it for us, right? So it's kind of like me giving you that stack of images. If I give you 1,000 images and I just say, group them together for me, right? There's not necessarily a name to it, but we start seeing piles that emerge, and this algorithm might help us classify or categorize things in ways we hadn't thought of. Then what we could do is, of course, we could create those categories, give them a name, but it's about the groupings or clusters that emerge from this model. So ultimately, we're trying to maybe create new categories that are more representative of what we're trying to do here, because we're basically feeling that the categories we have aren't good enough, and so people are just kind of defaulting to something, So the whole point here is that there's probably categories that we don't have that we need to create, but we don't know what those are. And so that's the bigger picture of number 2. Was there any other questions? I didn't go over this with you. So is there any other questions while we're on it about this problem formulation exercise that maybe you didn't agree with, or you're not quite sure why it is, in the solution side, why it was defined the way it was, or just, are we good? And if there's anyone who wants to jump up, go for it.
Yeah, so on number 4, I think I might have been thinking about it too much, but couldn't there be an argument that it could also be like a reinforcement learning, especially like if you wanted to include the routes that are going in there and determining, like, if you're trying to get both the customer and the driver's end, you got to make sure it's, meetable on both sides, and you have to include the route on that to make sure that's possible.
Yeah, I agree. This one's a tricky one because it's, the route does matter, but the actual problem that's posed to us by the business here is really just talking about parking spots, right? I mean, so to some degree, I would say that, yeah, you're probably just going beyond the exercise, right? You're kind of going beyond what the business is asking for you there. Now, can one influence the other? Of course, right? But really, it's about that stop at this stage. Okay, so maybe you create another model that's about the route to get there. Now, could the combination of both of those actually then be something that you look at to actually truly determine the best stop? Maybe, but maybe the route to get there is inferred automatically to some degree, right? So when you're talking about a stop, there's going to be data that's feeding this, right? So the data would naturally come from some of that, right? So it wouldn't be a good stop because the only way to get there is to go, 3 miles out of the way and go around and go over a bridge and circle around because of one-way streets and stuff. That's all going to kind of naturally come into play because of the data that's being gathered. The outcome of it all is still going to have a reliance on how you got there. You know what I mean? Like, so to some degree, you could argue that that is somewhat embedded in that decision. It's not just the fact that it's at a stop sign or it's at a something. There's more to it than that because of the information we're gathering. So it's kind of an interesting one. It depends on what the data consists of, really. So of course, there's going to be some trial and error here, but ultimately, customers can place a pin exactly where they want to be picked up, right? Just kind of clarify here for everybody. But the customers say drivers rarely stop at the pin location. But basically put a place where they can't stop, right? So in this case, driver's navigation, existing relationships to get direct backend access to their data, latitude and longitude, visual photos of each place, traffic delay details, right? Which is going to infer some level of routes and things like that. And then regulation data, like if you can't park certain places and whatnot. So the data may contain what we need indirectly, right? But that's a big question. It kind of does depend on what the data actually consists of and things like that. So as far as reinforcement goes, the problem with reinforcement, of course, is it's a trial and error, right? And so we just try it and we say that didn't work, try this other thing, and that works better, and so in a scenario like this, that could be tricky. Reinforcement might work. I don't know. I mean, that's one of those, just experiment with it and see. But probably from the sake of what the problem is trying to ask you to do, that's probably over the expectations, right? And so that's why they kind of just went through and said that basically we're just going to go ahead and label a bunch of things and say these are good spots, right? And someone will have to go through and label those and then let the system kind of learn what's in common with those labeled spots, basically. I mean, what kind of how the algorithm starts spotting and identifying good places, right? But yeah, that's a big if. I mean, you have to understand what the data is and how what kind of things it consists of, and this is where it's fairly generic in terms of what we have available to us. Until we actually see it, there may be some big questions there, right? But that's the big picture. Yeah, it's reinforcement. I mean, there's the whole like routes and stuff are a complex beast. I worked with a company a couple of years back that they were doing a lot of that. They were doing route planning and stuff for service companies, right? So like a plumber or somebody that has a bunch of stops to make and kind of planning their routes out for the day. And that's a really, really tricky thing. Google's, been doing that for a long time and they're still not perfect at it. There's unlimited routes in a lot of cases. So what's the best one? But that's not necessarily even reinforcement learning. There's all kinds of other things that come into play on that one. That's a complex discussion, a little bit beyond the scope of this class, but deep learning and other things would really start to come into play there, most likely. Probably not even reinforcement, probably deep learning, right? So, this is a tricky one. But looking at just kind of not trying to look too far into it, I would just say, well, they're asking for a spot. We're going to label a bunch of spots and say these are good, these are bad, and then let the system kind of learn from that, right? And then make predictions around that. Okay. So that's all it is. All right. So I know some of these are vague, right? I mean, in all reality, this problem statement, these are fairly substantial sized paragraphs, but You know, if I was writing this up for real, you know, in a business, I mean, this is probably maybe even a multi-page statement, you know, kind of going into all the details, putting bullet points about what you have, you know, more specific is better. That way there's no ambiguity to it. It's not like, well, you know, I mean, we kind of really, you know, understand what the business is asking us, and we want to be very clear about it. But Kip has a question. If you had UPS data, wouldn't ML not be required? Wouldn't ML be not required? Okay. So UPS data. Okay. So, well, I mean, UPS data is only part of it. It's not automatically stops for a passenger, right? So it's being included, but we're not just going to say that UPS. I mean, does it say UPS in here though? I mean, even regardless, showed up in the solution. Yes, I'm looking at the solution right now. That's why I'm kind of wondering where's the UPS. I think I remember seeing that as well. I'm trying to remember where it says it in here though. I thought I remember seeing that. End of 4. So here's 4. Oh, right here. Gotcha. So, oh, I see what you're saying. Okay, so that's just a question that's being asked. Yeah, UPS driver stop information could help. I don't know if I would just say use the UPS driver data. I would say it could be an influence, right? But I don't know. I mean, this is just thinking out loud. That's a good question. But we don't have it right now. Okay, I want to point that out. That's simply asking a question. What maybe we think about other data we could try and achieve, right? We could try and obtain. Then if we obtain the right data, though, maybe we don't need machine learning because maybe UPS is already doing the machine learning, right? If we already have that UPS data, maybe machine learning, maybe UPS has done the work for us, and now all we got to do is just get the stops, right? And maybe that's good, but I don't know if that's perfect enough or in a perfect alignment enough for for passenger pickup, right? Yeah, exactly. So Anna's got some great points there, and that's kind of what I was getting at. Is the UPS stops aren't for passenger pickup purposes, right? And so the data might be helpful, knowing that a driver can stop there. A UPS driver can stop there. Then perhaps a ride sharing company could stop there too, but we don't know that for sure. And also, UPS drivers sometimes get a little gutsy, right? I mean, they'll park like kind of right in the middle of the street and just say, "Well, I'll put my flashes on and just go do it," and nobody says anything. Just drive around them, But an Uber sitting in the middle of the street asking a rider to cross the street to get in the car in the middle of the street maybe isn't a good idea, So where a UPS driver can stop maybe isn't appropriate for a ride sharing stop, right? So it may be an influence. Maybe it's another column or another feature that we toss in and it helps improve our information, but I don't know if it's just one-to-one, right? If we do find the right data that is one-to-one, then yeah, we can maybe eliminate the ML problem altogether, but it's only because somebody else has probably done the ML work, right? It just means we're stealing somebody else's work at that point. I mean, which, it happens all the time in business and it's okay, but, so that's the thought process there, but yeah, great questions. And I like to think, that's the thing. We just need to kind of just, explore options and just kind of open our mind up to thinking of possibilities. And that's where this last question here, I think that is a good one though, to ask, is there other data that we could be trying to find, right? And could it be helpful to us? And that's really important, is maybe the data is appropriate, but we could be better, right? So that's kind of the message there. Yeah, great questions. Awesome. Okay. Well, good. So we took a short break. So we're just going to jump right into our next discussion, which is data preprocessing. Now we're going to get into the data discussion. Any other questions, by the way, while I'm loading this? Any other thoughts? Anybody wants to think out loud, statements, questions, whatever?
I added one to the chat here.
Yeah, go for it.
For the student project template, is the success metric the same as the business metric?
Oh, yeah, I believe so. Let me just double check, make sure that I'm going to look at the doc real quick, but I'm pretty sure you're correct on that. Let me just double check though. And you're talking about the student project template. Yeah. Yeah, that's technically, the wording on that's kind of weird because they're not directly aligning with what we've just told you. Let me just student project template. Just opening it up right now. The student project template, like I said, the wording isn't identical, but success metrics you could say are both of those are success metrics, right? So there's the model success metric and then there's the business metric, right? But in this case, let me just see, are you referring to because right here we've got, and am I looking at the right thing here? Yeah, the student project template.
Right, number 3.
Number 3, okay, yeah. So the business metric would be what, like in the examples we gave you earlier was, that at the end of the month, we have no more than 15% product on the shelf. We don't have a bunch of extra, we don't have 100% more than we need, but we also haven't gone with any missed sales, right? So we haven't run out of product. So that would be the business metric, right? So an actual measurable thing. So it's not just a concept here. There's a business goal and the business metric. And the business metric would be something measurable, but it doesn't care about the measurement of like accuracy of the model. It cares about the business benefiting from the model. And it needs to be something measurable. So something very specific, like in that case, we said 15%. So it needs to be, it can't just be faster, right? It can't just be, increase something or make something faster or be, have inventory on the shelf and don't run out. It needs to be a specific thing that we can measure. And so that's why, like that, in that example, we said 15% in the slides, because that's a specific, right? You can't, and so like if I want to improve something, I can't just use the word improve. I have to give it some, improve by 10%, or whatever. So try and come up with something very specific from the business perspective that is not correlated or directly related to the success or accuracy of the model itself, because that would be a model metric, which would be different. So that's kind of what we're getting at there, the business metric itself. But yeah, it is a success. The business metric is a success metric, but success metric is kind of vague in that it can include both the model metric and the business metric. Those are two different things. So when we talk about accuracy of the model, we're saying, okay, if I give it 1,000 records, it was correct 950 times out of 1,000. That doesn't mean the business is actually benefiting from that. It just means that the model's doing what we expected the model to do at the model level. But is the model even right? Maybe we have data that wasn't really helpful to us, or we took a path that wasn't appropriate, or an algorithm that wasn't appropriate, or whatever. So we're going to measure the model, but we need to step away from the model and measure the business success, right? And so those are kind of what we're getting at there. Okay, so maybe that helps, maybe it doesn't. I don't know.
It does. Thank you.
I know it's kind of vague, but yeah. Okay. All right. Awesome. So let's go ahead and talk about data pre-processing. Now we've got some checkpoints that we're going to do as well. Yesterday is kind of more conceptual. We have a checkpoint that a lot of times we'll start at this point and kind of go over the day 1 content, which at this point we're kind of starting the day 2 content. And we're a little bit, it's funny because the curriculum developers, it's all estimates and kind of ebbs and flows. Sometimes we don't get through all of one day's content one day, and then we have extra time the next, and so on. So very common that we don't actually start day 2 content until a little bit into day 2. Perfectly fine. So there's a checkpoint at this point, but what I'm going to do is probably combine checkpoints 1 and 2 when we get through the data processing stuff and we kind of get through some of that. So it'll include the first checkpoint's kind of more about problem formulation and that kind of stuff. And the overall pipeline, and then checkpoint 2 will be about data pre-processing stuff we're going to talk about now. So we'll kind of just do both of those together, kind of back to back. It's fine because we've kind of beat it now as far as the problem formulation exercise stuff. We've kind of just beat that down. So I don't want to keep going on that at the moment. Just I kind of want to shift gears and kind of get into the data, and then we'll kind of circle back and just kind of combine a couple of checkpoints. And those checkpoints are just kind of like a mini quiz just to kind of assess how you're doing and kind of how you feel about things. And then it helps new questions emerge, right? Okay, so data pre-processing. So now we're kind of setting the business problem formulation aside. Now we're going to start getting into that idea of, okay, let's collect our data, let's look at it, let's pre-process it, let's clean it up, right? So this is where the data work begins. All right. So data collection. All right. So first off, where does the data come from? It can come from many, many sources, right? In fact, a quick note on this. A lot of times ML work is kind of like an offshoot of big data. So we have another class that AWS teaches, that I teach as well, it's called just the big data class. It's big data on AWS. And doesn't use the word pipeline in the title of its class, but in all reality, that's what it is. It's about the big data pipeline. And machine learning is a lot of times a side shoot of that, partly because it's a lot of different data sources. It's not always, you don't just get data usually out of a single system. A lot of times we find ourselves getting data from multiple data sources. And so you have a variety of data, which is, high variety. It becomes a big data problem. It's not always going to be big data, but a lot of times it is. And so this kind of is a kind of almost a subset of the big data stuff. And so a lot of times we actually find ourselves working with data lakes. And if you're not familiar with this concept, I'm going to kind of highlight this real quick. There's this idea of a data lake. Now, many years ago, we didn't have data lakes. We just had data warehouses. And data warehouses are databases, typically relational databases that are massively parallel. They can go to massive size, petabytes and petabytes of size can be in a data warehouse. And the problem with a data warehouse is that it's highly structured data. So you have to structure your data to put it into a data warehouse, which means if it started off as unstructured, you have to go through some sort of ETL process, extract, transform, and load, and you got to load it into that data warehouse in some format. In the process of doing that, you also may have data that's been lost, right? Context that's lost and things like that, because structuring unstructured data, you may have to dump some stuff to get it in that structure, right? You may lose some stuff. In fact, usually the data warehouse is also very, very clean data. So the dirty data has been removed. Well, that in and of itself is a problem, because dirty data could be something that could be intelligence for us. In the machine learning space, I actually like to look at dirty data. There's been models I've been part of where what we've done is we've looked at raw data, dirty data and all, and used models to actually help us clean up the data, right? To help us identify why the data is dirty to begin with. Maybe we spot bugs in source applications where when a certain combination of features has been chosen, suddenly the data gets corrupt or it gets written incorrectly. And so it creates dirty data or missing values or things. And we help us, so we can use the dirty data to actually help us learn as well. And in a data warehouse, you're typically stripping out that dirty data or you're cleaning it up in some way. And you're kind of losing that insight of why it was dirty to begin with, or dupes, right? A lot of times we dedupe when we put it into a data warehouse. Well, why was it duplicated to begin with? And maybe we can learn from that. Maybe there's something hidden in that we are losing when we're putting it into a data warehouse. So a data warehouse is highly structured. It's usually a database. So you have like ODBC or JDBC connections to it and some sort of BI tool, like a business intelligence tool, like, some sort of front end dashboard or reporting system, right? Well, a data lake is kind of the opposite of that. A data lake, we put raw data in here, not cleaned. It has not gone through an ETL process. It's however the data was collected. Okay. And the idea of a data lake is there's no particular format. It can be completely unstructured. Any file format works here. I mean, you could have images, you could have videos, you could have text, you could have CSV, JSON, raw text, you could have emails, you could have, any number of things can be put into a data lake, and we just leave it in that original format. And so our sources come from that raw data. And in the machine learning, in the machine learning space, it's actually a lot of times better that we look at the raw data than the highly processed data. Okay, because the raw data is going to have the cleanest insight. It's not going to have been manipulated, right? So we get the cleanest insight into that data as opposed to something that's been processed. That processing action could actually create quite a bit of bias, right? By processing it, whatever logic is used to process it could actually generate bias of some sort. So to really look at the core source raw data is typically a lot better for your machine learning. Okay. Now we'll talk about that, because now that means that we're working with data that is dirty, that is, missing values and stuff, and your algorithms won't like that. So excuse me, 1 second here. So your algorithms will fail most of the time. They'll completely crash if there's like missing values. And then there's going to be values that, are incorrect. Maybe they're the wrong scale or something. So we need to clean that up as part of our ML process, but with the idea of ML in mind, as opposed to general data warehousing. They're not really caring about ML. They're just getting, you're getting it into a data warehouse for reporting reasons. And so the efforts used to clean it up may not be in alignment with what we're trying to do on the ML side. So very commonly, we're seeing data lakes emerge in a lot of organizations. In general, in the big data landscape, we're highly encouraging data lake usage as well. So machine learning is typically going to use your data lake as your data source. Okay. And so a lot of times you take all these different data sources and you can put the data into a data lake. Now it doesn't have to be, right? You could definitely get data directly out of a transactional system or directly from some other source. But very commonly, people take all these sources today architecturally and dump your data to a central data store. And this makes it really easy to be able to do things like big data and machine learning, all that kind of stuff, because the data from many different sources is kind of in one place, many different formats, but in one place, as opposed to having to connect to a bunch of systems. So integrations become a lot less, right? Instead of having to worry about, 100 different integrations against this transactional system, we may just dump its values to a data lake in a raw form. And then you could have hundreds of systems all talking to that data lake, right? And not worry about having to integrate with this transactional system. You don't have to have permissions. You don't have to have user access to this transactional system. Plus, if the transactional system undergoes changes, if we have a bunch of integrations with it, those changes become really problematic. If instead the transactional system is just dropping its data into the data lake, integrations aren't there, the transactional system can undergo changes all day long and it won't break a bunch of processes, right? So, so there's a lot of benefits to having a data lake in this context, okay? And as far as data lakes go, S3 is probably the best product to use in AWS for the purposes of data lakes. It's just in and of itself, it's like a perfect fit. It's unlimited storage. It's some of the most robust storage in AWS in terms of resiliency, durability kind of stuff. And it's also some of the cheapest storage in terms of cost. And so, and you can manage this and have all kinds of different, what we call storage classes, which manages your costs even further. So, as far as costs go, here in the US, S3 is about 2.4 cents per gig per month. Actually, I think it might have gone down now that I think. Now I'm doubting myself because I think there was a reduction fairly recently. I'll have to double check on that, but it's certainly not more than 2.4 cents per gig per month. Glacier, I know there's what we call a deep archive option with Glacier, and it's an archive service. We could go down to 1/10 of a penny per gig per month. So 1.1 cent per gig per month. Or another way to look at that is I could store 10 gigs a month for a penny a month. Okay. So, very good cost-effective storage options here. Archive is trickier to work with because it's offline, but I can work with it. I can say, let's perform a restore so that I can use it for some training, or I can perform a restore and run it through a bunch of predictive work and then get rid of it again, right? So, I mean, there's definitely use cases for archive with machine learning, but there is a delay, right? There is a latency there to retrieve your data, okay, as opposed to all of these others are active online data, okay? So a lot of different storage classes we can work with, but S3 acts as our data lake. And again, we can do machine learning directly against that data lake. We can also do analytics, which analytics can include machine learning, but not always, right? We could do a lot of analytics without ML, but ML does fall under the analytics heading, So again, what we can do here with S3, something else that kind of makes S3 very interesting, is we decouple our data from our compute. So what we do is, and you did this yesterday in your lab, but it was all kind of all inclusive, kind of a lot of steps, and a lot of the steps don't sink in yet, right? And that's okay. So we say, I want to go do some training. Okay, I'm going to perform a training job. I don't have to load my data into SageMaker. Okay. In fact, I don't. The SageMaker has no storage. Okay. What I'm going to do is now in our notebooks, keep in mind the purpose of a notebook instance is not to store data. Now, I know in some of the labs, we actually do pull CSVs into the notebook instance, but that's only so that as we're manipulating it, playing with it, and evaluating it, we're not having to work with remote data and having to move data around a lot. Okay. But when it comes to actually performing a training job, you perform the training job against, you tell SageMaker, go ahead and train. And you tell it where the source data resides. Okay, so SageMaker itself doesn't store the data. This training job, what happens is your training instances come online at the time a training job is invoked. And those training instances go look at the source data. Okay, so it needs permissions to that S3 bucket, but you can just point it to that S3 bucket and it'll use that data. Okay. And then the outputs of SageMaker, same thing. It doesn't have storage. SageMaker doesn't store the outputs. It stores the outputs on S3 again. Okay. So now these could be the same bucket or different buckets. That doesn't matter. Okay. So this flow here, this is more of a flow diagram. Like I said, technically this bucket and this bucket could be identical, right? They could just be different locations in the bucket or something, or they could be completely different buckets. It doesn't matter. But the outputs, which become your model, get stored back on S3. So really what happens is you have S3 as your source and your destination. SageMaker is just processing it for you. This is performing the training job. And you could have hundreds of training jobs all going against the same source data if you wanted to. Okay. So then at that point, if you want to deploy your model, the SageMaker deployment mechanisms, same thing, you just point it back to your S3 source of wherever your model artifacts actually reside. Now, this is that decoupling I was talking about yesterday. What's really neat about SageMaker is because of this model, let's say we train somewhere else. Let's say we train on-prem. We run a training job on premises and we have this model now. You could just copy that model right into S3 and have SageMaker deploy it right from there. Okay. So you don't have to do all this if you don't want to, right? You could just eliminate that first part and just focus on the last half, or vice versa. You know, if I wanted to, I could just perform training in SageMaker and take these model artifacts and copy them on-prem and deploy it somewhere else, right? Or copy it to another cloud provider for all I care. Maybe you want to run the model in Google or in Azure. That's fine, right? You're not stuck with AWS here. You're not stuck with SageMaker here, okay? So it's not like this big commitment level where you have to say, oh, if we're going to use SageMaker, we're committed to it. It's all proprietary and everything. That's not the case. Okay, the model that's created here can be copied around, can be used anywhere you want to use it. Okay. All right. So that's kind of the general picture there. Now, S3 is not slow storage. Some people mistakenly feel that S3 is, or think that S3 is slow because it's an object store. S3 has 100 gigabit networking behind the scenes. Okay. I mean, you get tons of networking capabilities, lots of big bandwidth. It's got unlimited storage, and I can do up to 3,500 writes a second with a single partition in S3. Now there's ways to do multiple partitioning. And so I could achieve tens of thousands of writes a second if I wanted to. As far as reads are concerned, Each partition can handle up to 5,500 reads a second. And I could, again, achieve tens of thousands of reads a second if I needed to. But it is still an object store. And there is a level of latency there. And so some people need something even faster, something even more robust in that sense for purposes of performance. And also the fact that we're keep writing and reading back and forth with S3 can be challenging at times because let's say I do a training job, right? And the source is S3. Let's just ignore this for the time being. And the source is S3 training jobs. Then the I'm sorry, let me back up. Sorry. Let's again ignore that this is here. And so I'm working in my notebook instance. Okay. I'm doing some analysis of the data, kind of visualizing and doing all that stuff. Well, maybe to do that, what I needed to do was perhaps copy the data from S3 into my notebook instance, look at it, analyze it, create my scripts and all that, perform a training job. And then the training job has to also suck in the data from S3. And, that may not be overly performant. Okay. And like I said, S3 is fast. So when I say overly performant, I've worked with systems that got millions of transactions a second going on. Okay. So the level of what we consider performant here, it can depend on your needs. And there's what's fast to one person could be slow to another, right? Or fast to one process could be slow to another. So S3 is not slow, but we can go faster. That's kind of the message here. Okay. So there's another system that we can incorporate here called EFS, Elastic File System. This is very similar to like a NAS on premises, network attached storage, where this is more like an actual file system. S3 is not a file system, it's an object store. And this isn't really the class we're going to go into detail around really the differences there. There's a lot you could discuss. But at the end of the day, this is something you actually mount. Okay, it's mountable storage. S3 is not. This is actually mountable storage, and it can become the core storage of a system, right? So I can actually mount a volume to a virtual machine, right? And it looks like a drive. It looks like a volume on that system, okay? That's what EFS is going to do. So what's going to happen here now, if I stage this data in EFS, now this is not going to live there permanently. I probably just take this and stage it for this process. What I can do is my notebook instance can mount that storage as a disk and just work with it as if it's local. Then when I go to train, my training instances come online out of nowhere, right? Keep in mind, when I perform a training job, the instances come online completely from scratch. Okay, those instances aren't pre-built. Okay, they come online, they get built at the time the training job is initiated. Then what happens is it just simply mounts that same storage, and it doesn't have to copy data around. It doesn't have to pull the data in. It's already got it mounted. Okay, so this can be a little bit more efficient. It is going to be more expensive. Okay, EFS is going to cost you more than S3. But it's temporary and it's just going to be negligible. It depends on how much you do here. You have to kind of analyze your costs and things like that. Okay. Okay, so good question about networking limitations and stuff. Yeah, I understand. I think what you're getting at. So when I say like mounting the storage, your operating systems know how to work with that a little bit more efficiently. It's actually seeing it as a local disk. Now it is network attached still. So there are still networking limitations. I want to point out in AWS, the network is so robust that your networking limitations are not networks at all. Your actual networking limitations are going to come from the size of this notebook instance, and the networking limitations are going to come from the CPU power and things, right? So the size of the instance and CPU is going to slow it down before the network ever does. Okay. The size of the instance actually denotes how much network throughput it has. So this is the case through all of AWS, not just ML discussions. So an EC2 instance, a virtual machine in AWS, a really, really small virtual machine might only have 100 megabit connection or a couple hundred megs. While you could also have monster systems that actually have 100 gigabit networking connection on it. But even then, if the CPU isn't big enough to handle it, it may not be fully utilized. Okay. So the system is where your bottleneck is, not the network. But with that said, S3 is an object store. It's using web calls. Okay. So just to clarify this just a little bit more about protocols is actually one of the bigger factors here. So without getting too crazy on the networking side of the house, S3 is a web call. It's an HTTP or HTTPS request. Okay. HTTP is not very efficient at moving data, not nearly as much as like network attached. So this uses what we call an NFS protocol, and this uses HTTP. Okay. All right. So NFS is meant for it's a network file system. It's an actual file system. So it's more intended or more designed for moving data around. It's a much more efficient protocol than HTTP. So if I want to read a file with HTTP, I'm actually performing an actual HTTP GET request against that object on S3. With NFS, it's an actual disk mount, and the operating system is working with it at a much more efficient level. It's not just making web calls. Okay, so that's kind of the bigger picture there. Networking itself is not really the problem. It's kind of more about the protocols being leveraged, the fact that this option presents itself as an actual disk. The operating systems of these systems play with it a lot nicer. Okay, so but like I said, it comes with a cost. NFS, this EFS, Elastic File System, is going to increase your cost because you're still going to have S3 most likely. You're not doing this instead of S3. This is actually a step what you would do to kind of queue up or kind of stage your data here. And then from there, both of these systems can use that data simultaneously and not really like copy the data around and have to do as much movement of data. It's a lot more efficient, but your cost is going to go up. Okay. Now, by how much? It may be negligible. It kind of depends on what you're doing here, how much data you're talking about, and all of that. But this will be more performant when it comes to actually performing the training job and working with your notebook instance simultaneously, doing all that. They can both mount the same exact storage at the same time. Okay. So Jeffrey also had a question here. So when SageMaker training job runs using training data on S3, does it grab all the data all at once with one HTTP request at the start of the job, or does it periodically query it? I'm going to table that question for now, Jeffrey, because we actually have a discussion around that to help go a little bit more in depth on that. It's not as straightforward of a question or straightforward of an answer as I want to give just yet. There's a little bit more context there. But it is having to do an HTTP request for each file. Each object gets its own request. Okay. So starting with that, but there's more we can do with S3 than just that. You can actually, I'm going to give you a real short answer for now. You can actually stream the data, meaning you don't have to wait for the entire object to copy over into the system before it can process it. It can actually start at byte 1, and as the data is flowing into the system, it can be processing. So, and that's with S3 even. So S3 is still fast. Like I said, I want to point out this. Some of these discussions make it sound like S3 is slow because we're talking about going faster, but this just means really high performance computing needs. If you have really large amounts of data, it might be helpful to stage them on EFS so that I can mount. Plus, if I have a lot of training jobs, imagine if I have a whole bunch of training jobs here, all hanging off of this storage, they're all mounting the exact same storage. With S3, they're going to actually have to copy the data into their system to process it. So to kind of Jeffrey's question there, if I was going directly to S3, each training job would actually have to copy or load that data in. It would have to pull the data in from S3 into itself in like a scratch space, basically, in kind of a temporary space. So it's a little bit less efficient there. So if I have many training jobs, this might make sense using EFS. Also, my notebook instance can use the same. So maybe I'm going back and forth. Maybe I'm performing a training job, doing more manipulation in my notebook instance and performing another training job and kind of going all that. Yeah, normally it's just RAM. Exactly, Jeffrey. So there is more to that discussion. It kind of depends on the algorithm, actually. Most of the time, yes, RAM, but depends on the algorithm. Some algorithms, it actually will stage it in some actual scratch space on the disk, but it's pretty rare. Most of the time we're talking RAM. Yeah. So yeah, so here's kind of another one. It's actually the same diagram or same discussion, just with yet another product. So instead of EFS, like back here, we brought up the topic of EFS here. EFS is, again, faster than S3 for this context. Plus, it's more shareable because of the mounting context. It's more shareable in terms of mounting it on multiple systems. Okay, multiple systems mounting the same disk, right? This one is the same thing, but at yet another level of performance. So FSX for Lustre is what we call this. You can go look this up. Amazon FSX for Lustre, if you want to learn more about this. This is discussed a little bit in a couple other classes, but this is for truly high performance computing. This is super high end performant data storage. So this service, I mean, it's designed to be able to have thousands of systems reading and writing to the exact same data. All right. I mean, it's not just a couple, but like, I mean, thousands of systems. It's under the true high performance computing, or HPC category, if you will. This is extremely performant. Of course, it's more expensive than EFS. So it's faster yet. Okay. Lower latencies yet. Okay. So again, if you're looking for some really high performance stuff, you could go here. I don't have a lot of customers using this because this is kind of like those one-offs when you have something really big, really important, really fast that needs to be done. So the other thing too we have to think about is if our training jobs, like I said, if I've got lots of training jobs, maybe I want to produce 10 different models with different options and features and settings, right? We'll talk more about those parameters later. And I want 10 different ones to run at the same time, and I'm dealing with massive amounts of data as well. Those training jobs could be really stressed, and you could run some pretty big compute intensive systems on the training side, but if the storage side is lacking, you're actually waiting for that to move around. You're losing out, right? And so in this case, I could have 10 different training jobs running, all pointing to the exact same source storage that's actually mounted on the system specifically for high performance computing. It's the storage should not be your bottleneck at this point, right? At this point, it's really just about the size of the instances. The bigger the instances, the faster it's going to go, kind of a thing. The storage should not be your bottleneck at all. Okay. So again, same thing. We load our data ahead of time. Okay. And then we could have many training jobs and notebook instances and all that running off this same storage, just like EFS. Just like I said, this is your Ferrari. Okay. But again, it's going to cost more expensive. It's more expensive than EFS. Now, expensive is relative because we're not storing our data here for very long, right? We're probably not storing our data here permanently. So even though it is more expensive, I would still do the math, kind of go out and run some calculations to understand what the costs are actually going to be. Because even if it's triple the costs, if it's triple, and triple means tripling 3 cents, now it's 9 cents instead of 3. You could see that wouldn't be a big deal. If we're talking about, it's going to be $3,000 instead of $300, that's a different discussion, right? So that's 10 times, I guess, but you get the idea. So, but anyways, you got to kind of run the math and got to understand if it makes sense. And so it is definitely overkill for a lot of things. If you have small data sets and you're just doing some pretty small models, this is probably not needed. And if you have only a handful of training jobs or a handful of systems you're working with at any given time, this is probably not needed. Okay. So it's about a progression kind of here, right? Directly from S3, the load times for your training data is just going to simply take longer. And then EFS is going to slow that, or it's going to speed that up. And then FSX for Lustre is the lowest latency option. So again, I'm probably going to store all this stuff here as a data lake, right? So I probably have the S3 cost no matter what. And so these other things are usually just a plus cost. Okay, these are just at additional costs for a period of time. And again, for how long, the storage charges you for time. So to clarify this just a little bit more too, almost every system that stores data in AWS, it's not just, that's so much per month. Okay, it's easy to kind of look at that on the pricing pages. It looks like it's per month, but it's actually what we call per gigabyte seconds per month. Okay, so it's actually down to the second. If I put data on S3 and I put it there for 10 minutes, I pay for 10 minutes of storage. If I put data on EFS for 10 minutes, I pay for 10 minutes of storage. put data on FSX for less for 10 minutes. I pay for 10 minutes of storage. So time is a factor here. And so even if something looks on the surface really expensive, it may not be, because I'm only using it for the afternoon. Right. So I stage it here, I perform my jobs, and then I get rid of it. All right. So so that's where, use the right tool for the job at the time you need it, but also don't go overboard though either. Okay. All right. So reformatting our data. So here's some raw data. Let's say this is like a CSV or something, right? You look at this raw data, you see we got some quotes around some stuff. We've got commas as a delimiter, right? And so, that is kind of an ugly way to look at data, right? And any of you, I'm sure a lot of you have experience with pandas, but some of you may not. If there's any of you that are not familiar with pandas, oh my gosh, you've been missing out. Okay, this is the only way I work with data now, programmatically, especially because it color codes it. It puts them in these nice, easily readable formats, and you're going to get exposure to this very quickly. But instead of looking at it, from a CSV kind of look, we're able to look at stuff in our, even programmatically. I can be doing my Python work and be able to see it in this nice, clean, formatted way, right? It's the rows are color, alternating colors like this. I can also look at things from a columnar perspective if I need to. In fact, there's what we call data frames with pandas. And the data frame is basically, your table or your collection of columns. Now those columns are actually a series. And so you see here, it's actually kind of able to work with the data in a columnar way. And I can simply say, I want that column and that column, combine them together and make a data frame. Okay. Even though the source CSV may be 100 columns, I'm only looking at these two right now, and I've created a data frame in memory that I'm able to work with, right? And so, so Pandas is very powerful when it comes to manipulating data. You can read and write to various source types, so it can work with Parquet files, it can work with CSV, it can work with compressed, uncompressed, binary, all kinds of options. There's a lot of data types it supports. And so I can look at that data source. I could save it in the same data source when I save it back, or I could save it as a different data type, when I save it back, if I want to save it as something else. So, Pandas gives me all kinds of flexibility in manipulating and working with data. So that's kind of square one, is working with Pandas. So Pandas, built into Pandas data frames, we can calculate statistics about the data. We can ask it for like the shape of the data, which is going to give me how many rows and columns it consists of and things like that. It'll help me clean my data, visualize it, do a lot of things just right in Pandas. Pandas by itself, without any other tools, will do a lot for you. Okay. So here's kind of the general kind of a Python code. It's very simple. Import pandas. Very commonly, people say as PD. That's just kind of a standard that most people use. When you see PD, we're talking about pandas. And then we have data frame. DF equals PD.read, and we're specifying our source. So we're reading that in, and that's our data frame. And so, but we can make other data frames from it using different series, using different columns and whatnot. So this is kind of our core, our starting point, if you will, saying here's the file, pull it in. Now let's work with it, right? And import files from many different formats, as I mentioned. You could work with JSON, and it looks like rows and columns. In terms of, a JSON file will still look like this right here, this formatted data. A JSON file will still look like that. A CSV will look like that. Anything we can make it look like that, right? And work with it very cleanly. So also, this is kind of an example here of what we say DF head. This dot head is kind of just going to show me the headers, if you will. It kind of show me the first few rows. So in this example, head 3 is going to actually give me the first 3 rows. And the point to this is to be able to kind of, maybe I've got a data file here. I've got a CSV or data frame that consists of, 100,000 rows. I don't need to look at all 100,000 to see if the format of the file looks correct, make sure things are, are the columns that I want here correct? Does the formatting look right? Does, kind of just get a glimpse into it. So usually we just use this dot head and say, I like to do like 10 or something, get a little bit more rows. I think 3 is kind of small, but kind of whatever you prefer, right? But it gives you a chance to kind of just get a glimpse into the file, kind of make sure things look right. Okay. And then df.shape, this will tell me how many rows and columns the data frame consists of. Okay, some dimensions about it. And then I can index things by different columns and all of that. Okay, now some other libraries we're also going to leverage here in this class. We're going to kind of give you some exposure to these. These are just really common tools in the machine learning space. There's a lot more. Okay, but if your portfolio of knowledge, if you will, exists of Python, pandas, NumPy, scikit-learn, matplotlib, and Seaborn, you're going to do 99% of what's needed out there. Okay, I mean, this stuff will handle just about everything you need to do. Okay, especially the scikit-learn. I mean, this is probably the go-to for a lot of people. Okay, so a couple of things to kind of explain what each one of these tools does for you. So NumPy, this is going to be objects with multi-dimensional arrays. That's kind of the work that we tend to do with NumPys. It'll do like n-dimensional array objects, things like that. It'll have all kinds of like broadcasting functions, and it'll also integrate with even things like I can use with NumPy. I can integrate with like C, C++, even Fortran code, and all kinds of other things we could tie into. Lots of algebraic kind of work, random number capabilities, all kinds of things that this tool supports. And then scikit-learn is really good for data analysis and data mining. So like I said, this is an interesting one because it's really a package of tools. It's actually built on, as you notice here, it's built on NumPy, SciPy, and Matplotlib libraries. So it's actually kind of a package containing these other things. And so the features of NumPy, SciPy, and Matplotlib are all kind of, for the most part, embedded into scikit-learn. So scikit-learn is actually just a really good just overall package. And this can be used in every phase of the pipeline. You could use this for visualizing stuff. You could use this for doing some pre-processing, deduping, all that kind of stuff, doing some calculations. We're going to talk about normalizing data, maybe changing scales of your data, doing what we call one-hot encoding. All that stuff, scikit-learn will help us with. Okay. A lot of algorithms. When we're talking about here, a lot of the algorithms that it includes, it will work with pretty much all of your major mainstream ML algorithms that you might choose. Okay. Matplotlib is a visualization library. Okay, so this is more two-dimensional plots, NumPy arrays, things like that. So it'll give you like scatter plots, bar charts, histograms, all that kind of stuff. And it works directly within your Python scripts, Jupyter notebooks, shells, and so on. And then Seaborn is also a visualization library. You notice here, this is built on top of Matplotlib, the one we just showed you in the previous slide here, right? So Seaborn is kind of like your polish, okay? So it's really making attractive graphs. So it takes the data from Matplotlib and really kind of makes it a lot more presentation-like. So this is a great tool when you're sharing out and you're maybe even personally, though. There's cases where I always prefer Seaborn even for myself because of the color coding and some other things that it can do. It makes things very apparent. So if you recall, like our scatter plot examples we gave you yesterday with clustering and things, and you take a group of all these dots on the screen, but maybe I want to color code them and I want to maybe even provide different shapes of the data. So in other words, instead of just a dot, certain data types are a little triangle, certain data types are a dot. Okay. And so it gives me a way to kind of glance at the data and really understand what I'm seeing very quickly because of the color coding and because of that stuff. So it gives that extra polish that makes it just that much more informative to us. And also, like I said, to others, if we're using these to present to others in discussions around the data. Okay. So those are the tools that we're going to kind of leverage and talk about. There's plenty of other tools. This landscape is enormous, just like the big data landscape. There's kind of unlimited amounts of libraries and tools out there, but the tools we've just mentioned pretty much cover the core of it all. Okay. So cleaning up, and by the way, we're not going to try and teach you all of these tools inside and out. We're going to give you exposure to them. there's bound to be tools or stuff that you've never seen before, even if you are experienced here. So maybe it kind of just opens up the door to kind of understand what's possible. And then of course you could spend unlimited amounts of time learning these tools, right? So cleaning up dirty data. So let's kind of start talking about this for just a second. Here's some data. Okay. We've got missing values. We've got all kinds of things wrong with this data. So we're going to need to do something with it. So this is part of that pre-processing phase, right? Keep that in mind. We're in that pre-processing phase. And so a couple of things we're going to spot that's wrong here. First, this column actually has the wrong language inserted in here, right? And again, if you're a company that works globally or something, this may be common, right? And so we need to maybe normalize into the same language, right? Or if there's slang or other things, make sure we normalize this. So we're going to want to make sure that this is translated and done properly. Okay. Also, you notice here the scales are different. So one says 45,000 per year, the other one says 1,500 per month per year, right? Pick one. If we need this column to all be on the same scale. That doesn't really make sense. If they're in different scales, it's going to throw things off. Okay. So we could write some very simple code here. This is kind of find replace kind of code. So you write some scripts. Okay. Yeah, we're going to get to that. Yeah, absolutely, VJ. We're not done. We're just showing you some initial things that you could write some very simple scripts for. So these things aren't going to require a lot of advanced work at all. Okay. Income is scales. That's easy. I just make some very simple scripts, very simple calculations. I say, oh, if it's represented in per month, let's convert it and put the new value in. Okay. Very simple, nothing advanced at all has to be done there. Education column where we got the wrong language. Let's just do some language translations, very simple code, right? This is not complicated to fix at all. But what do we do that 154 years old? You're absolutely right. We need to pay attention to that, but that's going to be something that's more advanced because what do we do with it? It's not just a simple script to say this equals that. Okay. And just out of curiosity, before we get to that topic, any thoughts from anybody in here? What are some of the things we might do with that 154? Do we just leave it or do we do something with it? Yeah, absolutely. We're going to get to that too as well. By the way, Genevieve. Yeah, we're gonna get to that too.
Maybe if you have the date of birth, you can actually get the age out of here. If you have that additional data.
Oh, so if you have other data, you could compare it with. Because this is the data that's been provided to us. So assuming maybe we have more than one data source that has this age, yeah, you could probably confirm maybe there's a clean value somewhere else. Yeah, that's a good point. So we got a couple of thoughts here. Replace, or actually we use the word input here. So input the median or input the mean. We could do that. Remove the data point. So Anna brought up the point where we remove it. Well, if we remove it, I just want to point something out here. If we remove this, we can't just remove the value, can we? Because then we create a blank value. So if we remove it, we have two choices: remove the row or remove the column. Okay. Input. Yeah, exactly. Yeah. Input. Yeah, exactly. I understand. I know what you're getting at. Yeah, exactly. Not input like, yeah. Thank you for spelling that. Yeah, exactly. Yeah. Exactly. All right. So in this case, though, also in the state, you notice here we've got some mixed up data, right? So this actually belongs over there, doesn't it? Right. So another more than one feature in the same column, right? So we're going to talk pretty heavily about that, Anna, because if you move the record, you're talking about the whole row, right? Yes, you're right. Partly. Because removing it also skews. Okay, removing it has impact as well. And we don't want to ignore that. So there's a thought process we're going to have to go through here as far as removing data. We're going to get to that. Okay, we have a whole discussion around that. So I kind of jumped ahead a little bit on that thought, but we'll get, just because it was brought up. But we've got some good discussion around that coming up. So more than one feature in the same column. We're going to probably have to have some data science work performed to handle some of this stuff as well, to understand that, oh, that actually somehow ended up in the wrong column, right? Probably due to some CSV issues. comma issues, and that happens, right? So we're going to need to spot some of that and fix some of that stuff too. So these are like, so far, if you notice, this set of slides actually hasn't brought this up yet. Okay, this is going to come up in a couple of slides. Technically a part B of this module. They broke it up into two. I don't actually know why, to be honest, because that's a pretty short module by itself. But let me bring up the second part to this real quick, because it jumps right into those next discussions around, age and some of those others. So let me just pull that up here. Quick question, totally off topic. Has anybody here upgraded to Windows 11? I did, and my office is super slow since my upgrade. I was really holding back, and I don't know if I like it. I've been avoiding it for a really long time, and it just kept bothering me. And I said, well, I've got multiple systems, so and Mac, of course, different set of issues. Not the same issues we deal with on Windows, but yeah, I just kept, and so I said, all right, I'm gonna upgrade one of my systems and see what happens. And I don't know. All right, yeah. Oh yeah, special issues is your game. Yeah, Mac. It's funny because you can say, oh, I'm on a Mac, I don't have that problem, but you got your own set of issues. There is no perfect system out there. All right. Okay. Anyways, I was just curious because my office, just in general, it doesn't matter if it's PowerPoint or Word or anything. It's been painful. My CPU has been going crazy. I gotta figure out. I may have to uninstall and reinstall. I don't know. Maybe that'll help it. Just since I moved the OS, maybe I have to reinstall Office to clean it up. I'm not sure. All right. It's just that all of our a lot of our stuff that we do for training is typical PowerPoint stuff and other things. And so it just kind of made sense to not fight it and just go with Windows. But I'm more of a Linux guy myself, but for this stuff, I use Windows. Okay. So data preprocessing part B here, if you will. So this is kind of just picking up where we left off. What we call descriptive statistics. Okay. So there's two here that we need to look at. And the question here is, these are outliers. I think we can look at age and know that that's wrong. But that's only because it's a very apparent column. We know there's nobody alive that's 154 years old. Okay. However, I would argue it depends on what kind of data this is. What if this is data going back, 200 years or 100 years or whatever we've got data for? And we want to actually denote the person's age as of today, whether they're alive or past or not, So maybe that's a valid value, right? If this isn't just people that are alive, maybe it's age as of today based on their birth date, regardless of their status of health, right? So I don't know. I mean, that's a big assumption, but I'm just throwing that out there, that we also don't want to just assume that 154 is a wrong value. We need to know, okay, this is maybe this is an active customer base, then obviously 154 is not a good value. Income, is that right? Well, I don't know. Is it possible somebody can make $3 million a year? It is possible. Okay. Is it possible a 20-year-old's making $3 million a year? It's absolutely possible. Maybe they're the next there you go, TikTok influencer. Awesome. You just don't know. I mean, it's weird. I mean, there's people that are highly successful at very young ages. I actually worked with a technical company, like a VAR reseller, that back in the early 2000s, that had no limits on sales. So if you were a good salesperson, your commissions were unlimited. And there was a guy in his mid 20s that was one of the top salespeople, and was making millions a year. I don't know exactly what his income was, but it was millions a year, and it was pretty impressive, right? So anyways, We don't know, right? So some of this stuff we may have to guess on. Some of it. This might be where you could get a, do some research, right? You may have to dig into some of these values, because here's the thing. You could, if I have 1,000 records I'm training on here, and this is the only one that's questionable, for sake of time, for sake of energy, no one's probably going to miss this record. Okay, so I might just go boom, and I might go boom. Okay, so if I delete 2 records out of 1,000, it may not hurt us too much. What if I've only got 20 records or 50 records I'm training on? Well, now removing any records could actually skew these other columns, right? Because now that doesn't get represented. Keep that in mind, that by removing this entire record, or any record you might remove, you're also removing representation of these other columns that are valuable data. Okay. And now you might have just removed a couple of really key data points that could have been important to our predictions, okay, to our training efforts. So there could be a correlation here. There could be something unique in the fact that this person making this huge dollar amount is in California. I don't know. So what if everyone with a super high value we just removed because they're outliers, and turns out they're all from California, and now California is not even represented, and we've just skewed our data. So the idea of leaving it in, right? If we have relations to other columns, wouldn't it become skewed? Well, removing it skews things too. Okay, you can never get away from skewing things. So we want to do minimal skew, but we don't want to cause too much bias or influence here. And that's exactly it. We'll create a bias if we start removing too much. Okay, so we got to be careful with that too. And we need to understand, are these outliers natural or artificial? Is it a data error or is it real? Okay. Oh, there you go. You can miss an entire client base. Exactly. Yeah. So, you got to be very careful. Got to be very careful with removing stuff. And so first off, we want to know, if we can, if there's a way to identify if these outliers are artificial or natural. Natural means this is an outlier, but it's real. So we don't want to get rid of it. Okay. Meanwhile, this is an outlier, but it's probably fake. It's probably a typo. It's probably an error in the data. So if we leave it, it will skew things by leaving it, right? Because, what if I said average age, just straight up average, this number is going to throw our average age off. And if I have enough of these, it could really throw it off, right? But it's definitely going to throw it off one way or another. Okay. What if this person's actually only 15 and the 4 is just a typo, an extraneous number that got put in there, right? So instead of skewing things, instead of moving the average down, it moves it up and it pulls you away from your average, right? So we got to be careful with outliers. Are one of the trickiest things we're going to work with here. Okay. So we're going to talk about some of these things, how we clean up some of this stuff. So pandas can help us with some of this stuff and kind of get us some descriptive summaries of this stuff. Understand what the count is, the mean, the standard deviations, the minimums, the maximums, all that stuff. Okay. So it's going to allow us to see this. So here's an example of descriptive statistics. We're going to look at age, and we're going to see that we have 86 unique values. Most frequent value is 83. The least frequent is 103. We have a mean and a median. Okay. Now, the mean and the median are the same here because this is common with age. That, it depends, obviously on our client base or what kind of data this might be. If we're only dealing with customers that are, all in their 20s, then you may have some different numbers here. If you're talking about just all general population, then your numbers are going to be different yet, right? So keep that all in mind. But it's possible mean and median could be the same, but they also may be different. It depends on on the balance of the data. Okay, so here's another one with income, unique values, most frequent, least frequent, mean, and median. You see here the mean and median are different. This is because if you go back to for some of you it's been a while. Some of you work with mean and medians regularly, but these are different, right? An average is just simply taking all your values and dividing it by the number of values you have, and that's it. The problem with that is, if I include 3 million a year, the 99% of our table here is 45,000 a year. This 3 million is going to move our average off, and we're going to actually move in the wrong direction. It's going to give us a miss number. In fact, the bigger this number is, the worse that's going to be. All it takes is one record. And, what if this was 30 million, and that one record is going to make my average way off. So we want to maybe decide, are we going to do mean or median, which takes weight kind of into consideration, right? And outliers, how much they're going to impact us and things like that, right? And so, in this case, there's categorical stuff like education. So there's only 5 separate categories. So we have 5 unique values, okay? So Pandas is able to provide all this stuff to us. Okay. This is really helpful with Pandas to start with. There's more tools that we're going to talk about, but just right in the base of Pandas, we got all kinds of capabilities here. Okay. So again, mean and median. If we have symmetrical distribution of our data, they're going to be the same, but that's actually kind of rare. It depends on what column we're talking about. A lot of times we're going to end up with something more skewed. And so there's a difference. Are we going to want to use the mean or median? Every situation is different. It kind of depends on if we're, wanting to kind of give it some sort of a weight to some degree, right? And I mean, I kind of using that loosely, but in this case, the average, as opposed to the majority of the records, are over on this side. So the median is a little bit different than the mean, right? Okay. So outliers also, if we visualize, this kind of goes back to that whole visualization thing. It's really easy to spot outliers, right? So a couple of things you can do with visualization that is really helpful. I can look at this and pretty much go, okay, I see a general line here. I see a general idea of how the data is shaped, how the data is kind of panning out. And I can also see these, values as being outliers, and maybe I want to see what those are all about. Maybe even, what's up with that one, right? I don't know. But it's really easy to kind of spot some of these things, and this is why visualization is so important. Okay. But outliers, again, they can be faulty, right? Like a typo or error in your data. They can also be highly valuable if they're real. Okay. So it can add richness, right? So take that $3 million per year income. If it's real, I probably don't want to get rid of it. But I also don't want it to throw my numbers off too much, right? I don't want to suddenly come up with the fact that, oh, my average is way off because of that one number. So how do I figure some of that stuff out? Just out of curiosity, is there anybody in here with ideas on how you would handle these outliers? Any thoughts? Is there anybody with experience on this that can throw an idea out there, even if it's stuff we haven't yet talked about? Okay. And again, I'm not going to go too deep into it right now because I don't want to jump ahead. I'm just trying to see if there's anybody. Okay. So Anna, so what if you look at each point manually and you've confirmed they're good? We need to use this stuff for training, right? So what are we going to do? We're going to leave them. We're going to get rid of them. We're going to do something with them. That's the question. Yeah. And you might look at each point manually. That's very possible. But what are we going to do with it once we've looked at it? So I like that one, Joseph. Scaling. Okay. And you could replace the median. Here's the thing. If you replace with the median, didn't you just get rid of the richness? Right. So you've actually replaced a quality number, a real number, with something that is no longer real. Aren't you introducing bias if you do that? You're getting rid of a value that's, so again, taking the idea of sports athletes, right? Professional athletes making millions and millions of dollars. And you say, I'm just going to make it say that you're making $45,000 a year. Wouldn't that give you false information? And the answer is yes, it would. It would actually make your predictions off. It would create a bias. It would cause problems. So it's actually not a good idea when it comes to real values. If they're errors, we might choose to replace with a median. or mean. It depending on the situation. Okay. So in like that case with the age, if I don't know what the person's real age is, I don't want to leave a false value in there. So I would probably swap it out with the mean or median, depending on the scenario. Okay. But a real value, probably not a good idea. There's other ways we can do that. Yeah, I agree, Jeffrey. So outlier detection, like DB scan, it'll detect. I agree, detect, but detection is only part of it. What do we do with it once we've detected it? Okay, and that's the question I'm kind of getting at. Let's assume we've already detected it. What do we do with it? What do we do with it? Do we remove it? And I'm just getting you thinking. I don't need answers at the moment. I mean, of course, if anybody wants to try. Okay, what do we do with it, right? Because if we leave it in there, it's going to throw my values off. If we leave it in there as is, it's going to throw things off like averages, right? If we change it, we're losing richness. If we remove it, we're losing richness, and we're creating skew and bias. So how do we keep it in there, keep it relevant, keep it part of our data set for training? There you go. Maybe change some sort of weight, Odette. Okay, I like the way you're thinking. Okay. Black swan territory. We'll talk about this because this is really important stuff. This is stuff that's scaling. Yeah, scaling is probably one of your best options, Desiree. In fact, we're going to talk about that pretty heavily. So I'm just going to leave it at that for now because we have some discussions coming up that are going to talk about exactly that. But I just wanted to get you thinking ahead of time before we start getting into the conversation. Okay. Well, that's an interesting one, Jeremiah. Huh. I hadn't thought about that, but that's a good thought. Something you could play around with. You still probably want to weigh that, because if you do that, that's another feature. And is that feature actually helpful, or is it going to create bias? You know, it could actually be a dimensionality problem at that point. So we'll talk more about this. Let's move forward. I just wanted to get you thinking first, and then as we talk about it, kind of start to click a little bit more. Okay, so here's some more information just kind of show you without or with the outlier. This is why we're saying the outliers are actually important to keep. Okay, if the outliers are false, they're going to throw things off too. So it kind of highlights both of this, right? So without or with the outlier, we see how some of this stuff is substantially different. Right, we're kind of showing you these examples. The mean, look how different that is with the outlier versus without. Okay, standard deviation. Oh my gosh. Right. So outliers, if they're real, we really got to keep them. Okay, so if they're natural, we want to keep them, but maybe do something with them so that they don't hold as much value. So the idea of scaling or the weight, like Odette mentioned also, those are all good things to think about. We'll talk about exactly those. If they're artificial outliers, though, like I said, this is wrong. If we left that there, that would throw our stuff off negatively, right? Leaving the 3 million a year makes sense to leave because it's value, it's richness, it's important to keep. Okay, so one we do something with, the other one we don't, as far as whether we're going to retain it or not. The 154 is obviously false. So if we don't know the real year of this, the real age of this person, we probably want to replace it. Okay. So a couple of options, and we've discussed all of these already. Okay. So one option is to delete the outlier. Okay, if it's an artificial outlier, you could delete it. Now, here's this slide's a little bit weird. There's different strategies out there. This is an Amazon provided slide. So this is just something that somebody in Amazon kind of came up with. An option is to delete the outlier. But if we delete the outlier, we're probably deleting the whole row. But as mentioned, we come back here. If we delete this whole row, let's assume that there's values here as well, and they're not blank. If I delete that, I'm also deleting an entry for masters. What if there's only a handful of masters records in this whole record set? Because proportionately, not a lot of people have masters or PhDs. And so by deleting that, I've just deleted another representation of a master's PhD entry, right? And whatever other values might be here. Now, in this particular example, I would look at this and go, yeah, deleting that's probably going to be best if I just delete the whole row, because it's also got 3 missing values, right? 3 missing values and an incorrect value out of these, was that 1, 2, 3, 4, 5, 6, not including participant ID, 6 features, and 4 of them are bad, get rid of it, right? That's fine. But if this column were, if this row were complete, and the only thing wrong with it was the age, removing it could have a problem, right? If, like I said, we're talking 20 rows that we're dealing with for our training data, if it's a really small training data set, getting rid of this is a problem because that's 1/20th of our record set, right? If it's 10,000 rows and we get rid of one, who cares, right? So the context matters quite a bit here. But if it's artificial, deleting it is an option. Artificial outliers, also inputting a new value is acceptable. You could be reinforcing the mean or something though, right? So keep that in mind too. You're actually strengthening the mean, which is also a bias. So no matter what we do there, we're going to create some sort of bias probably because we are conceptually coming up with what we're going to do with this. Deleting it creates bias, inputting a new value creates bias. There's always a bias introduction here. Okay. And we're not necessarily going to be able to get away from that. The question is how much it skews things, right? And decide on that. So there is a human decision that's going to have to be made here. Okay. We're not going to get away from that. Natural outliers, again, you could use the mean or something. So going back and saying, you know what, that 3 million a year, let's just make it a mean and call it a day. Under some conditions, that might be okay. Okay. But as mentioned, if you have a whole segment of customers that are, athletes, professional athletes, and they're all making millions a year, and all of them show that they're making 45,000 a year, and your model is meant to predict how much somebody's going to make, you're probably causing a whole new problem, right? You're creating a massive bias, and you're going to be wrong a lot. So there's no one answer to this. There's no cut and dry black and white template. You got to put our thinking hats on and experiment and play with this. Yeah, go ahead.
Yeah. So let's say you're dealing with a data set that has like thousands of rows. Could you, for example, like if you want to really find how much someone's making, and let's say there's like 50 different professional athletes or 10 professional athletes.
Yeah.
Not just taking the mean of that column, but get more specific and get maybe the median or mean of that specific profession to get a more accurate, because like if it's like a surgeon, for example, that, salary is going to be much higher than, if they're working retail.
Exactly. Yeah. That's an interesting thought. And that's absolutely acceptable. I think this is where, the science part of all of this comes into play, right? The definition of science is challenge. And, the ideas of science, challenge it, experiment, hypothesize, play, that's a lot of this stuff. You don't necessarily know the outcome until you try it. So some of that stuff I would say, go see what happens, right? And then test your model, because ultimately you're going to find out, is that making your accuracy of your model go up or go down, right? So, if at the end of the day, you're trying to predict something specific and your predictions get better with what you've done, then you're probably on the right track. If they've gotten worse with what you've done, then you're on the wrong track. So some of that stuff you can just experiment with and create 10 different models with different choices being made there. But I could see, you got a bunch of rows, you got 10 professional athletes in the pool. There's not very many, but if I go changing all of those to something really low, so maybe I do the mean or median of the athlete incomes. I don't know. This is where you can do anything. You can get really creative, right? Just think through what the potential impacts of your decisions might be, because you do need to think higher level on that, right? You got to kind of think it through and kind of go, what kind of other skewing could I be creating here? If all of the professional athletes are all saying they're making the same, is that a problem or not? Even if it is very different than all the other numbers, maybe that's a value though. If we're trying to predict something and the algorithm could have the potential of predicting something for a professional athlete, maybe that's not your goal, but it's a segment of your customer base. So wouldn't you rather like the model to be able to say, if it's a professional athlete, predict something different than if it's somebody's, in retail, right? And so how much is that going to affect it, right? So there's some big questions to kind of be thinking about there. But like I said, at the end of the day, experiment, just go try, create some models and see what they do. There's no harm in that, right? So I don't know if there's a right or wrong answer to that. There isn't one really, but it's about just kind of making sure we're thinking about these things. So these discussions we bring up and basically say, look, we're bringing all these things up. We're giving you some potential solutions to it, or kind of solutions, but there's no blanket answer to this stuff. We just don't want you to ignore, right? So the point of a lot of these slides is just to get you thinking, not to just give you a recipe for solutions. It's just a lot of people don't think about some of these things, or somebody has given them a recipe and said, oh, just put the median in every time, because that's going to throw off your average. So just change it, and if we're not really thinking through our decisions here, that is going to make our model perform poorly. Okay. So just, that's the big thing, is just to kind of open up the creative juices, if you will, and kind of think about how these impacts might be handled. So as far as missing data, also same thing. We're probably going to want to put some data in here. Again, we have some choices: delete the rows, delete the columns, or input, right? And so input, right? However you pronounce that, yeah, but it's not. And yeah, the spelling was established earlier. I've heard different, depending. Depending, I think different parts of the world, right? I've heard different emphasis on different things on that, however you want to say it. So in all reality, again, blank values, what do we do with them? Again, we want to analyze some of this stuff. What if we have a column here? I'm just randomly circling one. But what if we got a column here and 3/4 of the column is just missing? Inputting values in here probably doesn't make a lot of sense, because the column's probably not helpful already. If 3/4 of it's missing, we're not going to just make a bunch of stuff up, because we're absolutely going to create bias in doing so, right? At that point, I would argue the column is worthless. Drop the column. Okay, get rid of the column. The feature is not capable of being used at the moment unless that data can get cleaned up elsewhere. We're not just going to make stuff up. Okay. Another problem you might have is when you have categories like this. Okay. What do? This isn't a median or mean discussion anymore. This is not a number discussion. So what some people might do here is make a new category, right? Which is like undefined, or something like that. So at least all the blanks have a value, and it doesn't cause your algorithm to crash. But it's set aside, kind of knowing that we're not going to just say, oh, let's just put everybody in California. That's going to cause all kinds of bias, right? So undefined would probably make more sense, or create a category that's unique to those blanks when it's categorical kind of stuff, right? But when it's number values, something like income, maybe mean or median makes sense if it's blank, right? Again, creating bias here, no matter what, you're creating some sort of bias or some sort of skew, right? Because the whole point about putting a median in here would be, we're not caring about this one record. I want to point out just what we're going on here. Some people have a hard time grasping this initially, just because maybe you're thinking about it from a reporting perspective. If I want to know how much this person makes and I just make up a value, I'm obviously wrong, right? No matter what I do, it's probably not what they're making. So, but that's not what we're doing here. This is not business intelligence in the sense that, I'm not trying to find this person's, this isn't about a report. This is about predicting future outcomes. Keep that in mind. This is about tweaking our training data to make sure that our future outcomes are as accurate as possible. Just keep that in mind through this whole exercise, because a lot of people try and think of this more as like a reporting perspective. And somebody says, oh, I want to know analytically what the average income is. That's not what we're doing here. So the whole idea of skew is a little bit different. The algorithm's trying to find patterns in the data, and that one record is not going to throw off our patterns a whole lot. And so if I just use the median, it basically is something that's just kind of average, kind of just, it doesn't really show any special circumstance. So the machine learning training process is not going to really be skewed a whole lot from that. Now, again, if I have half my records I do that with, that's a little bit different. It's going to learn from that. So imagine, put yourself in, again, back up, put yourself in the shoes of a human being learning something. If I give you 1,000 pictures and one of the pictures I improperly labeled. Okay, just giving you an example. I give you a whole bunch of pictures. One of the pictures has a bad label on it. Do you think that's going to change your learning a whole lot? If it's the first 3 pictures and the third picture is off, yeah, because I only had 3 to begin with, I'd probably go, wait a second. But then as I go on, I'm going to start to realize that was improperly labeled, right? So I mentioned, I gave you the number. You probably didn't hear it. I know I speak fast sometimes. Like 1,000 pictures. Okay, so if I had 1,000 pictures and one of them was improperly labeled, it's probably not going to mess up my my learning a whole lot, right? But to that point, what if I had 10 pictures and one of them is improperly labeled? That's a much bigger difference, right? So we have to understand the amount of data we're dealing with here, but we do want to always keep in mind this is for the purposes of training to help you predict future stuff. So even if I only had 10 pictures, and one of them was wrong, if I have a pool of pictures, I got a couple of trucks, a couple of cars, a couple of motorcycles, a couple of airplanes. I got 10 pictures total. And one of the trucks is wrong. If there was only 2 examples of trucks and one of them was wrong, I'm probably going to have a hard time identifying a truck unless I look at a truck and I go, well, I don't know what else it could fit into, right? I know that's not a motorcycle. I know that's not an airplane. I know I'm going to guess it's a truck, right? Even if one of the 2 truck trainings was wrong, mislabeled. So it's questionable, right? I'm just illustrating it as a human being. That's all I'm saying there. In all reality, though, we have to be very critical about this because this will throw off. But how much it throws off, we may not know until we just perform a training job against it and put the model to a test, right? It may be fine. It kind of depends on the algorithm and how much it impacts. But obviously, the more rows we have, the less this will impact it. Okay, but inputting an average here, or a median or mean or something might be okay. But deleting it might cause a whole new problem because, like I said, we're also then removing representation of other columns, and we got to keep that in mind because maybe now again, maybe there was originally 2 pictures of a truck. Now I only have 1 picture of a truck, and it may not be enough to identify future trucks. Right. So, just to kind of give you that concept. So removing entire columns can have removing entire rows can have a whole different connotation. But we have the option of removing rows and then removing columns as well, removing features. If the feature isn't represented enough, you got too many blanks in here we have to deal with, it's not worth trying to fix because we are going to make a bunch of stuff up and it's going to cause us issues. Okay. So missing data, makes it also hard to interpret a feature target relationship. So, maybe particular states have very particular education balances here, right? It's very possible. What if, as a side note, there may be some other issues here that we need to kind of just be aware of. What if there's a bug in the software that every time somebody has a master's, that the state gets left out? So what if I were to come in here and replace, put this value input a value here that that is different, I'm going to assume that everybody with a master's degree is part of that category. Or what if I remove this, right? What if I remove this? Now I have no representation of masters. Okay, so it looks like masters don't exist. Okay, we're just trying to give you some examples, and then there's some pandas capabilities here. Where in this example, we're actually looking at just education and state and kind of giving us a chance to kind of analyze some of that, right? So we're creating a separate data frame just with this stuff in it. So it gives us a chance to kind of understand the relationship there, okay? Pandas also gives us, again, some more statistical information, things like looking for nulls, okay? So like in this case is null, and I can look at things from an axis of basically rows or columns perspective. So I can look at things from a column perspective or from a row perspective. If I do axis equals 1, it's going to be based on a row. If I don't provide the axis, the default is column based. Okay. So we can look for those blanks. Okay, is null. All right. Okay. So why are the values missing? These are all very important questions to ask. What caused the missing values? Maybe there's a bug in the software. Maybe there's somebody was doing some manual exports and they just messed up the CSVs in the process. Who knows? Is it actually random, or maybe it's not, right? As we saw in the past slide, maybe everything with a particular value like master's PhD causes a blank somewhere else. So you're kind of looking for some of those things. And in fact, that might be opportunities for your own ML models for that purpose, right? To help identify that stuff. So keep that in mind, that we could use ML to help with the blanks environment, maybe change our whole objective and go, let's try and find our blanks and why they're blank. I have worked with customers where we've done this and we've used this to find bugs in software that we didn't know existed, right? We go, what's going on? Every time we produce this data, we've got this error in the data. Why it seems like it should be clean, but it's not. Well, let's go ahead and create some models and see if we can figure out what the patterns are, if you will, in that, right? And then here's the hardest of it all. Learning what you don't know. Okay, how do you know if all of the columns are actually there? Maybe the export was supposed to include certain things and it didn't. And you received the data and you were never told what that export should have contained. And you don't know that you're missing data. You're missing entire columns, right? Or maybe even the exporter didn't know that certain features existed, or certain columns could have existed, or certain rows. Maybe certain rows got omitted based on some filter that was applied that you didn't know, right? These will cause bias no matter what. Okay, I mean, you create filters, you create, lack of information can create bias, choices of information can create bias. All this stuff is going to create some sort of bias somewhere, somehow. Question is by how much. But ask this question. This is something that a lot of people fail to ask, is let's go look and confirm. Is it possible that there's stuff that we're just not aware of? And let's seek that out. Let's assume that there is stuff missing so that we can be certain that we're not forgetting something. Okay. Dropping missing values. Again, nice thing here is when we do decide to drop something, pandas will be very good about this. We can say, let's just drop all NA, right? All null values, let's just drop them if that's what we want to do, right? We could do that. And maybe that makes sense under certain conditions. So pandas will make that easy for us. We don't have to go through and find them row by row. Okay. So dropping those, no problem. Okay. So again, we've talked about this, okay, but risk of dropping rows. Now you don't have enough training samples. We create what we call overfitting and actually may bias it. If we drop columns, we could be actually removing entire features when we do that, right? Oops, sorry about that. So you may lose information and features if we drop those entire columns. A column is a feature, right? And so we lose that entire feature, and that could be a feature that could have been helpful for us, and now it's not there, right? So we need to understand the risks, okay? All right, so missing numerical data with scikit-learn. okay, in putting this numerical data here. So scikit-learn, again, another great tool for us. This is some pretty cool stuff that it'll do. Look at this. We just simply say, input it with a mean. Boom, done. Okay, we could actually do this. We could have 100,000 rows, and we run this tool, and it'll go through and put the mean everywhere. All right. Not a lot of work that's going to have to take place. This is where these tools are invaluable. You don't have to write all the logic for this. The library already does it. It's built right in to do that. All right. So now we go ahead and we say, okay, this income value, this was missing before. We're going to go ahead and put that median there. And then we went ahead and deleted this row. All right. So all good there. All right. Well, PowerPoint's struggling here. Give me a second. Don't know why it's so bad. Okay. Hold on one second here. Stop my share for just a second here. So I know sometimes the share can cause some issues. Let me. Looks like PowerPoint's hung on me. Can you hear me okay still? Just making sure we're still good on the Zoom side.
Yeah.
Okay, awesome. Okay, I'm gonna have to, I do think I'm gonna have to reinstall, I think. At some point. Not now. I'm just gonna have to deal with it for right now, I think, but okay. And we're about at lunch, so just bear with me. We're gonna let you go here in just a second. Just let me kind of button up this conversation here real quick. Apologies. Maybe I'll do this evening. Reinstall, see what that makes a difference. Okay. Actually, you know what? So looking at this, where kind of good stopping points. So the next section is about data visualization. So I'm actually going to stop there. I think it's a perfect time to stop for lunch, actually, looking at the time here. So let's go ahead and come back in an hour. Again, gives you plenty of time to hopefully respond to some emails, kind of get caught up on work that you're falling behind on, things like that. So we're at 12:17 right now. Let's come back at 1:15. Okay, just easy numbers, even round numbers there. So 1:15 Eastern. And then we're going to come back. We're going to get you started in the big lab of the day. We're going to start working on our projects here soon. So the data processing discussion, when we wrap this up, we don't have a whole lot left on this. We'll wrap it up after lunch. And then we're going to get you into your bigger labs, and you're going to start working on this stuff in your own projects as well. So a lot of good fun stuff happening this afternoon when we get back from lunch. So let's see you back here at 1:15 Eastern time. That's an hour from now. Okay. They're just shy thereof. All right. We'll see you then. Have a great lunch. Welcome back. Go ahead and mark that you're back and ready to go. That would be great. Awesome. Good. Okay, so welcome back. Hopefully you had a great lunch and got some of those emails responded to and whatnot. I'm sure work's just flowing still. Always makes these classes kind of tricky. Okay, so we left off kind of talking about how we're working with this data, right? So blank lines, just those are easy to get rid of. Blank values, are we going to put in some value? Are we going to remove the row or remove the column, right? And those are all discussion topics. Those are all possibilities. Okay. Then, of course, making sure all of your values are as they should be, right? The proper scale, so that the scale for the column all matches and stuff, right? Find those outliers, natural or artificial, all that good stuff, right? And then we're going to talk about visualizing our data here. So a couple of things, we got things like categories here, right? Visualizing categorical data. It's pretty easy. You just go ahead and put it in a plot of some sort of bar plot or something. Looks, this is pretty easy to visualize categorical data, kind of see how they relate to one another, right? Numerical data, all right? We got something like this. Well, here's histograms and stuff that we can work with, right? So there's things like how many peaks, are there any skewness, right? Is there any, is the data normally distributed or not, right? So in this case, you can kind of see that obviously there's not a lot of records that are in this much higher dollar income range, right? But the bulk of our income range falls into this 15 to 314,000 US dollar range, and then the rest is all kind of separate. So it's not evenly distributed, if you will, right? So we can create histograms from pandas data frames pretty straightforward. Again, this is all kind of built right in here to pandas, so you can see we can do df.hist, okay? And you can specify again what your some of the values around this stuff, right? So you specify some of the stuff around your data frame, and then you've got your histogram that you're going to create from that, right? And then we've got density plots and box plots, all sorts of things you can do here. And of course, this is that whole data science aspect of things. I mean, this isn't a course to teach you how to read all these things, right? So, learning how to leverage things like box plots or candlesticks, all kinds of things that we might find ourselves using. There's a skill in visualizing and understanding what this actually means to us, right? And so that's a little bit beyond the scope of this course. So correlations. All right. So a couple of things. We're going to also want to identify correlations between attributes. All right. So we don't want correlated data. And we'll explain what this means here in just a second. But here's our scatter plot and scatter plot matrix. By the way, this correlation stuff, we have charts separate for that. We're going to get into more detail on correlations later. But there are, again, more charts and things that we can work with, tables and whatnot, to kind of help us with these correlations and stuff. And then other visualizations, scatter plots matrix, things like that. Again, here's kind of an example here, df.plot.scatter. You see how that kind of plays out. So we kind of plot that way. Now, of course, this is where other tooling might help us expand on this, make this a little nicer with things like color coding and other things, right? Now you're going to see this scatter matrix here, and it looks something like this. With enough skill, enough time, you'll start to realize there's certain visuals of data that kind of represent the data in a certain way. I'm honestly not all that great at doing this visually, but I've known some people that can, perform these scatter matrices and matrices and really kind of get a very good understanding of their data by just a quick glance at these visuals, right? So you kind of see how the data kind of relates to one another, right? Relates to itself, if you will, in ways by being able to read some of these things, right? But here's kind of an example of that scatter plot a little bit more enhanced with color coding and shapes and stuff with identification, right? And so again, we got plot.scatter here, right? But you see, you kind of read through the examples here. I'm not going to get into all of it, but we're color coding it and we're giving it a marker, right? So in this case, we have a V, if you will, another one being an O, all right? So so now we end up with a very different view of the data, right? If I go back a slide or two, this one right here, this is what we're showing you here, okay? But now we get a very different understanding of that data, okay? Now we start to see, oh, okay, maybe this is, you know, again, cancer, this is kind of like cancer or something, you know, so malignant versus benign. And so now you start seeing things look a little bit, quite a bit different now that it's color coded. So this is the kind of stuff that also helps us very quickly at a glance understand some of our data. Now, getting back to the correlation stuff, this is really important. So let's take a brief moment to kind of dive into this a little bit more than some of the other things we've gone through. So correlation, what do we mean by this? So I don't necessarily care what a particular value is. Don't forget, an algorithm that's applied to our row is looking at all the different features and including those all in the algorithm. So remember that very beginning of the class, we went over that very simple algorithm where it was weights. You know, you had the product, you know, how many purchases, this was a hat, yes or no. We had product, you know, weight, if you will, right? Well, that's kind of some of the stuff that the algorithm's going through. And then it's adjusting these weights in the process, right? So here's the thing. What if we have two values that we're using in our features? Don't forget, a feature is a column, okay? So we have two columns of information. One of them is sales and another one is revenue. They seem like kind of related to one another, but are they really necessary to have both? So here's the thing. Do we know for a fact that as sales increase, so literally the number of sales, if we have a column of number of sales, as the number of sales increases, we also know simultaneously revenue will increase, don't we? We know that for a fact. Now, revenue is not profit. That might be a different discussion. But if we're talking revenue, they seem like they're two very different things. One is a count of sales, one is a dollar figure. But at the end of the day, to an algorithm, they kind of have the same effect, right? So as one goes up, the other goes up. One goes up, the other goes up. One goes up, the other goes up. And they're always going to kind of follow that pattern. So we actually don't want highly correlated data. So at that point, you're probably going to want to pick one of those two columns, not both. Okay, they're too correlated. So correlation just simply means that they both kind of mean the same thing to the formula and could actually cause bias. Okay, it causes quite a bit of bias, actually. So this is another one of those mistakes people make, is they leave highly correlated columns or features in place. We want to reduce that down. So what we do is we run this, what we call this correlation matrix. And the correlation matrix, each one of these is a feature. Okay, so if we have 9 columns, we'll have, actually this is 10 columns, we'll have 10 features, okay? And then what it does is it intersects itself, okay? So feature 0 and feature 0 intersects itself. Feature 1 and feature 1 intersects itself. So do you think it's going to be highly correlated to itself? Of course. So it's going to have a correlation of 1. 1 meaning 100% correlated, okay? And then some of these others means that it may not move exactly 1-to-1, but it moves so close to the other feature that it doesn't give us any value. Okay, so we really kind of want to draw a line here, and this is where we may experiment with this. A lot of times people will discard any features that are correlated more than like 0.8. Okay, 0.8 or 0.9, get rid of those. Those are probably quick and easy things you can get rid of. But you may play with that line. Some people might say, well, maybe even a 0.7 can go, but maybe not. And you want to kind of test that. So you may actually want to create 2 models. One that you've gotten rid of a column that was correlated by 0.7 and one more, maybe you left it in, and see if that feature creates bias or whatnot, right? And of course, you could see the performance of your model to see if if it hurts or helps you, right? But let's just say we're going to get rid of all 0.8s and 0.9s. Okay. Well, we can look here and you can see, look at this feature 3 and features and feature 2. Feature 2 and feature 3. And of course, if I go 2 and 3 here, same thing. So 0.9, those are highly correlated features. So what we're going to want to do is look at 2 and 3 and decide which one to keep. But we're going to want to get rid of one of the two. Okay. Feature 2 or feature 3, one of them needs to go. All right. Now, which one? Technically, you could be creating bias through your choices here. So again, that's going to be some experimentation. Maybe you try one with the other. Who knows? But one of them's got to go. Okay. And then, we can look for other things that are similar. Now, you notice here, this is a negative 0.9. So we know negative. So what this means is they have an inverse correlation that also is just a bit too close. All right. So as one goes up, the other goes down almost exactly in the same amount. Almost, not quite, but almost. So we see F6 and F5. Of course, I could go F6 and F5 here, right? They're both a negative correlation of 0.9. So the range here is -1 to +1. 0 is the least correlation possible, okay? And then we kind of increment from there. And so here we've also got another scenario. We got F5 and F6. Pick one of the two, okay? We've got another one here, 0.8. We might want to choose to get rid of as well, another 0.8. So you see, kind of try and find these things. Now, this correlation matrix is helpful, but this is where, again, color coding can make it that much easier for us. So if we instead use like Seaborn, we can end up with some really nice coloring here. So by the way, you can do this heat map. Here's an example of some of this. But if we actually use Seaborn's going to make this really simple for us. So if I back up, this example is a way to do this using just kind of a lot of your built-in stuff, or use like NumPy or something. But if we expand on that and use Seaborn, very simple, very, very simple lines to make this happen. So Seaborn's got a lot of this stuff built right in. Okay. So you see here, this color coding really helps me spot this out. It's the deeper the color, the closer to correlation it is, right? So 0 is going to be clear. Okay. It's going to be just white. Okay. And then green is your positive correlation. Purple is your negative correlation in this context. And of course, the closer to 1 it is, the more solid the color looks, right? Or the deeper the color looks. So you see here, the 1 is the deepest green. We've got this negative 0.9 here, negative 0.9, negative 0.8, inverse correlations. We've also got 0.9 right here. So that's green, but it's just it's not quite as deep as the 1, right? But it's definitely darker than some of the other greens. Okay. So this helps us kind of, our eyes just spot this really easily. So this is where doing manual work like this, where we're kind of just evaluating our data, and we're kind of looking at the different features that we've got. We can easily spot those highly correlated columns now. Okay. So again, if we come back here, highly correlated features, right? So we look here, yeah, we can try and look for those numbers, but it's just a little harder on your eyes, and it's very easy to overlook stuff. It's really easy to overlook stuff. But we come over here to color coding it, use Seaborn in the process, and it just looks, whoops, went too far. And it's just a lot easier to identify this stuff. Okay. Yeah, so PCA, we're not really going to get into the depth of using PCA to deal with correlated features. That is definitely a discussion. But yeah, we actually, yeah, and what you're basically saying, kind of clarify for the class here, and I really like what you're bringing up there. We don't really get into it too much in this class. But that is something that you can definitely do. Yeah. So in this case, maybe combinations of features that are highly correlated and kind of work through that. But again, at the end of the day, we don't want to keep both correlated features as an input here for our training process. We want to get rid of one of the two. But that's where PCA can actually help us with some of that stuff. So yeah, just a little note. It's good for people to know that you can do some of that. I would say to go play with that. So the nice thing about AWS in general. If you're not experienced in implementing it, go try. I mean, it'll take you 5 minutes. Okay, you can go experiment with that right now. You'll see how quickly and easily this stuff is in AWS when we get to doing it. There's no reason why you couldn't experiment with some of that stuff and learn it right now. It wouldn't be a whole lot of work to go play with that, right? So I would encourage that. And that's one of the things that's kind of nice is your learning curve should be a lot faster in AWS because you don't have to go build systems for this. You don't need production systems. At any point in time, you can take some data and you can just start playing with it and implementing those things very quickly, very easily. You could train 100 models in an afternoon playing around with stuff. Okay, it's not overly difficult at all. You'll see how simple SageMaker makes this stuff. So this is for reference in your slides. Any of you that are really deep dive data scientists and actually want to go down into some of these formulas, these are specific formulas you can go reference. Now, this is far beyond the exam and far beyond this course. Okay, this is just here as reference. We are not going to go through and walk through each one of these and really kind of go deep into these. This is just extra. So some people come to this class, want this stuff. I would say a large portion don't. And in fact, part of the reason why we use SageMaker is so that we don't have to worry about a lot of this stuff, right? But if you really want to understand what's going on behind the scenes, mathematically and whatnot on some of this stuff, it's nice, to be able to dive in deep if you want it. Okay, so we provide this as just a reference. The notes on this slide also kind of go in a little bit onto some of this stuff for you here. So, so this is good to kind of reference if you wish to do so. Okay, but otherwise, I'm not going to go into any of these at all. These are just various correlation formulas. Okay, covariance, correlation between couple. We got variance, we got Pearson correlation. So this helps you maybe. Some people, it helps them actually understand better about what's going on if they're really mathematically minded. It's kind of helpful to see the formula going on there. Okay. All right. But again, like I said, extra. So for some people, that's an overwhelming slide. For some people are like, oh my gosh, I never even got to that level in school in terms of formulas. They're getting stressed out. And some people are like, or it's been 30 years since they had to deal with formulas like that. So for those people, I'd say just don't worry about it. Don't stress over it. It has nothing to do with the exam. You're not going to see stuff like that on the exam. Okay. All right. So that's kind of the big idea. Now, this whole section, this whole module 4, part A and part B, we started kind of with storage. We talked about that S3 storage and then the EFS as well as FSX for Lustre. Talked about pandas and some of the different tools we might use, kind of showed you some of the visualization stuff, the different matrices that we might work with and so on, right? So just kind of recapping on that. Now we're going to get some hands-on finally. Okay, so here's how this works. We have 2 portions to our lab time, and today, tomorrow, and Thursday, you're going to follow this model. We're going to have a practice exercise first, and the practice exercise is to kind of teach you a concept. Okay, actually, working with the code, kind of walking through. And that practice exercise doesn't have you create a lot of code yourself. It's kind of showing you some of the calls, walking you through some of the stuff. And then you have your project work. And you're going to do the same concepts, but you're going to apply those concepts to your project itself. Okay, and it's going to ask you to try and create some of the code. Okay, when I say some of the code, the way it works is you basically have some skeleton code or really you kind of have some core code. And then there's sections that they're going to have you try and figure out. Now, the whole point of figuring it out is go reference the documentation, and there's links to that provided. You can go try and do some research, find Pandas documentation, find the Seaborn documentation, also the SageMaker calls that might be required and so on. But don't forget, the practice exercise also introduces you to most of that. So whatever you did in the practice, you could probably kind of think it through and kind of go find the documentation on some of those calls and see how they might correlate. Okay, or I shouldn't use the word correlate. How they might come through there. Also, there's a solution. Okay, so I'm going to show you this before we set you loose. There's also a solution file, so you can take the solutions and just basically copy and paste them in, right? As opposed to having to figure it out. So if you get totally stuck, you're not really stuck. You can always take the solution. There's a couple of rare spots where I think the solutions have errors, unless they fixed them recently. I know they did release a new version of this lab of these labs, all of them for this class. So I think the revision may have fixed some bugs, but it's possible there could still be some bugs in the solution, but most of them are pretty solid. There may not be any bugs at this point, I'm not sure, but I know the last class I taught this class a couple weeks ago, actually probably closer to a couple months ago now. It was before the holidays, and there was a couple of bugs in the solutions, just a couple, and it was only for very specific projects, like, oh, that project on that step has a bug, that kind of thing. So keep in mind that's possible, but you're going to try and do this work on yourself. So the point is, it's better if you can figure it out for yourself. You'll have better learning, right? If you go through that exercise, but at some point, don't get stuck. Okay. What I don't want you to do is have this turn into a 4-hour endeavor. Okay. At some point you go, okay, I get it, move on, or I'll have to research that more later. I'm just going to use the solution, drop it in and move along. Okay. Don't spend like a half an hour on one step trying to figure it out. Okay. That's also not what we're doing. Okay. At some point we do have to move along. So we're not going to give you unlimited time to work on this stuff right now, at least not during class. So just keep that in mind. I don't want you to get stuck and hung up on one task where you got, if you got 20 tasks and you're stuck on one for a half an hour, you can see how that could really set you behind. And then you won't finish, and then you'll have to play catch up and stuff. So we don't want that. All right. So you're going to have a practice exercise, and then you're going to have your actual project. And then we're going to basically do this all in one window of time. So you're going to do your practice, and then as soon as you're done with that, you're just going to move right on in to the project. Okay. And I'll explain more about this moving forward here. So just sit tight for just a second here. I'll explain it all. Okay. Now, this last part in red, let me explain what we're going to do here. So after you do your project work, at the end of the day, at the end of the project today, so at the end of this window of time, when you're all done with the tasks for the day, you're going to save your project files. This is the Jupyter Notebook file. Okay, you're going to save it locally on your computer somewhere. Put it somewhere safe, but not just on the lab server that you're going to be using. And the reason for that is the lab environment gets destroyed, right? It times out and it goes away. And so you'll lose all the work today if you don't do this last step. Okay. Tomorrow, what's going to happen is you're going to upload that file into the environment and basically start kind of where you left off. Okay. So you're only going to do part of it today, and then you're going to download it. Tomorrow, you're going to upload it, do some more work. At the end of tomorrow, you're going to save it again. And then on the last day, you're going to upload it again, and you're going to do some more work. Okay. But if you don't save it, you're kind of losing your work. Now, if worst comes to worst and you forgot to save it and that's that, you could just, use the solution to kind of just get to that starting point again. But it'd be better if it was your work. Okay. We don't want that to have to happen, but if you can, there is a way out of it. There's a way around it. So, it's not end of the world, but better off if you save off your file. So don't forget that final step. That is really important. Okay. Basically it says right here, 120 minutes. We're going to give you 2 hours. This is a long window of time here. So 1:30 approximately right now, 2:30, 3:30, 3:30, 4 o'clock, somewhere around there. We're going to go ahead and start class back up again. I'm going to, don't hold me to the times just yet. I'll let you know when we actually set you loose, because that may take a few more minutes of explanation here. So we are not going to present anything to the class. Okay. The first portion, this exercise, and it says right here, break to review. We're not going to do that as a class. So ignore that line. Okay. What I found is it's better if people all end at different times. So instead of just having you sit around, it's better that you move right on into your project work. That way you kind of have, more time for your project at that point. This is a very, very much a varying time. I've done some classes where people want 3 hours for this. And I don't mean just one-offs, like 1 or 2 people want that. I'm not going to do that. But if, a bulk of the class is like, hey, we'd like more time, I'll give it to you. And this is where we have some flexibility here. So it's your class, and I don't want to cut you short. Okay. But on the same token, I don't want you to create a bunch of extra time requirements by, like I said, getting hung up on one task, saying, darn it, I'm going to answer this myself. I'm not going to use the solution. you're doing yourself a disservice if you do that to too much of an extent. I'm with you because I'm really, that's who I am. I have a problem in front of me. I'm going to solve it no matter what. Right. And sometimes if that just takes me hours, that's just kind of what I do. It's who I am. And I know some of you are probably in that same boat. But that is not our intention here. I don't want you to fall way behind because you took half an hour on one step. Okay. At some point, resort to falling back to your solution file and looking at the solution and kind of getting an idea of what it's trying to teach you. Okay. If you can't get it fairly quickly, we don't want you to just hang up for too long on one thing. Okay. So this first section, you're going to do the project work. This PE dash file here, I'll show you. It's PE dash data pre-processing file. PE stands for, personal exercise, so that's the first exercise. And that takes this whole exercise takes about an hour. Okay. In all reality, it says, really like 40 minutes, but when it's all said and done, about an hour, you're probably going to go ahead and probably want to take a small break in between. I mean, 2 hours is a long time to go without any break at all. So usually as soon as you finish your project, you'll probably want to, or your exercise, you'll probably want to take like 5 or 10 minute quick break. Just don't take too terribly long. Don't abuse it because you're just losing project time when you do that. But try and take whatever breaks you might need along the way. And then you're going to move into the project files, and you'll notice that there's a file in here for each project. Okay, and this is where the project instructions begin and exist here. So I'll show you this firsthand. Let me log into the lab real quick. I'll kind of give you the lay of the land, and then we'll set you loose on this stuff. So let me go ahead and open up my lab here. So this is just my lab. It's the same lab as yours. And we're going to go into SageMaker. And if you actually look at the lab itself, the instructions right here, if you scroll down the instructions are really just saying, I know it says 240 minutes here, but like I said, it can be 2 hours or more. We can kind of, whatever you need. Okay. But if we continue down here, you'll notice it says log in. And basically you're going to connect to the notebook instance. And from there, do everything in the notebook instance. That's it. Okay. As far as solutions, again, there's a solutions file. I'll show you where that is real quick. And then when you're all done, download the project into your local computer. Okay. Download as. All right. So that's all the instructions are in here. The Quick Labs instructions are not really your instructions. In all reality, your main Quick Labs instructions are really just, hey, go connect to the notebook and then do it all in there. Okay. Yeah, great question, Alexander. If for some reason you finish way early and only like 10% are finishing early and the rest of the class is all just working and wanting extra time, then yeah, I would say research some stuff, right? Go in and research some of the calls that you did, dive in deeper into some of the SageMaker stuff. Go ahead and play around too. I mean, feel free to experiment at that point. Just make sure you do save off the file before you start tweaking it even further, so that you've got a good, clean starting point for tomorrow. But yeah, there's a lot you can do here. You're not going to be short of that. And then, of course, if you want, you can go over to the WebAge portal, and there's a bunch of resources in there. So you can start reading some of those and doing a little kind of prep, kind of studying in that sense as well. Okay. So there's a ton of resources on that end too. But yeah, either way you want to handle that. But people are going to finish at different times. It's going to kind of stagger. So I'll give you a time when we get started here. I'll give you an actual time of when we're going to reconvene, at least as a check-in. So a lot of times what I found is I like to check in after 2 hours, but a lot of people will then say, we would like more time. And so that's where we kind of, judge it at that time. Okay. We don't really know until we get, closer towards the end there before we know if we're going to need more time or not. So that's all. So we'll talk about that here in just a second. Let me just show you real quick though. Where did I go? Did I not? What on earth did I do? I thought oops, that's not what I meant to do. Thought I had my lab open. Oh, I did. It's just another window. Okay. Okay, so so here I've got SageMaker notebook. Now your lab is going to already have a notebook in here. Okay, so you created a notebook yesterday so that you know what you need to do there and kind of understand the notebook creation process. From this point forward, you're not going to create any notebooks. They're already created for you. You just connect into them. And a real quick note on this, again, just kind of like I showed you yesterday, if I were to look at this notebook, you'll see that there's this lifecycle configuration, and this is the script that ultimately pulls in all of the stuff you're going to be working with. Okay, so it kind of takes a little bit of liberties on some cheats and shortcuts just to kind of get the data rolling, so we can focus on the calls and not too much about copying data all over the place and all of that. So but let me show you inside this notebook instance what to expect, and then we'll set you loose. So here's the main notebook. All right. Now you'll notice this PE, data preprocessing. That is your personal exercise. And you'll notice you have your Python cheat sheet here as well. But there's also some data down here. And you're going to use some of this stuff in your labs and whatnot. There's up here, you have projects and solutions. Okay, so just as the name implies, if I go to the solutions one, there is a PE solution right here. Okay, so the personal exercise, same thing. There are solutions to that. Now, I don't think this one, there's a whole lot to solve. If I recall this one, this exercise is kind of illustrating a lot of commands and whatnot, but there's not a lot it has you type in. I think it already does a lot of it for you. In fact, let me just open it up real quick and take a quick peek. So we'll see what the exercise looks like here. If I, if I scroll down, so read all this, right? Gives you the business scenario and all that. And then you're going to run these cells, right? So like you're going to have to run this cell here. You're going to see there's a CSV that we're going to work with here. It's already put in for you. And so most of this stuff, I know it says right here, enter your code here, but the code has already been put in. So this was one where originally they had you do tasks in here more than in your project. They had you do a bunch of this code yourself, but people got hung up a lot more on this. So they decided through the exercise to kind of show you, and then in the project, you'll put a lot more of your own code in. So they left the comments here, but in all reality, most of the times it's already done for you. So there is no code to be put in here. It's already there. Okay, so it's just asking you, hey, go ahead and here's a question or a task you could do. Let's take a look at the first 10 rows to see what the data looks like. If this was blank, then you would want to put in that, but it's already there. Okay, so just run that, kind of walk through some of this stuff, kind of understand what's going on. See more scenarios like this. Basically, they went through and answered it all for the exercise, just to kind of speed things along, because it was taking people way too long to do the exercise this way and their project this way. So they said, you know what, we're gonna move those tasks more to the project. Okay. No, when the pre-processing notebook is done, if you want to save it for your own edification, by all means, you can feel free to save it. But that's not a requirement here, because the exercise, when it's done. Tomorrow's exercise is completely independent. We don't need to upload it and all that stuff tomorrow, just the project. Okay. Yeah, great question there. So this is the exercise, going to kind of walk you through some of this stuff. Okay. Then if we go back to the projects, this is where, what project are you doing? Are you doing the reviews project, the fraud project, or the flight delays project? You're going to pick yours, whichever one you're doing. Each one uses different algorithms and different approaches because of the problem's different, right? But you're going to come in here, and then this is where you're going to see it's going to have a lot of tasks for you, and you're going to need to do the work for that task, and that means coming up with the code for it. And like I said, there is a solutions file. I don't know why this is me yesterday too. So if we come in here, it's kind of giving you some information about the data. Don't forget, this exercise is right now, today, we're doing pre-processing. So this file, if you look at it, let me go all the way down here. You'll notice we keep going, data pre-processing. And then we're going to go all the way down here, end of lab 2. So this is where it tells you to go ahead and save it. Okay. Today, we are not going into model training. Okay. That's for tomorrow. Okay. So we're ending right here where it says end of lab 2. That's where we're stopping for today. Okay. Up until then, though, you see there's these sections, enter your code here, These are not done for you. Okay. So you need to do it. All right. One thing I just want to point out, kind of like yesterday with the bucket, you're going to have a bucket here as well. And when you do put that bucket in, don't forget you're going to go back to your quick labs, and it's provided in there. So over here you have this lab bucket name. Use that bucket name, and don't forget no brackets around it, right? Lab bucket name is provided. Okay. So somewhere in here, I don't remember where it's going to ask you to, right here, change the bucket and prefix. Okay. So the prefix actually doesn't need to be changed, I don't believe. You can read what it tells you to do up here. But the bucket name, I'm going to come over here. I'm going to copy this. I'm going to come over here, remove the brackets. Okay. And put that in. All right. One note, and I'll mention it again tomorrow. But tomorrow, when you upload your project, what's going to happen is you're going to actually have to change this bucket name because you're going to have a new bucket tomorrow. Okay. Every lab is going to have its own independent bucket. So that's one of the key things you will have to change each day. But otherwise, everything else you can just kind of work through from top down, and then tomorrow we'll do training, and then, we'll kind of keep progressing. Okay. So this project file is going to be kind of a living thing. We're going to keep enhancing it, keep expanding on it as we go through the following days. Okay. So that's kind of it in a nutshell. All right. Any particular questions before we set you loose?
So you just go to file, save as, and then that's how you get it.
Great question. Yeah. So from here, when you're all done, file, download as, actually. I mean, you can also save it on the local computer, but that's rather not the local, the server you're on, the notebook instance. But like I said, that's going to go away. So you want to do download as, and you want to download it as a notebook file. Okay. Don't download it as a PDF or something, because that's not going to be what we want it to be. Okay. You want to download it as a notebook IPYNB file. All right. So download as, when you're all done, that's notebook file, and then save it on your local computer. And then tomorrow you'll upload it. All right. So tomorrow you'll do like new notebook, actually not new notebook. You're going to actually upload it tomorrow back on this page, right? There's actually an upload option here. So, so that's the big picture. Okay. Any other questions? I'm going to be here for you, but it is going to be pretty quiet for the next couple hours as you're working. But if you need me, I'm here. I do take my headset off during most of our lab times and stuff, just because it does kind of get, cumbersome throughout the day. But if you want to grab my attention, just use the chat, and we can always move back to audio and have a discussion if we need to. Like I said, if you need a break, take it, but just try not to take too much break. And we want to make sure you're getting things done and not causing, a staff to wait or whatever, just because of breaks. So in that regard, we'll kind of just check in and see how everybody's doing in about 2 hours. Okay. But I suspect we'll need more time than that. But at the 2 hour mark, we'll just check in and we'll kind of assess how far people are along and kind of get an idea. Okay. Now, one final thing. I've kind of had mixed results. We can go one or the other ways. There's 21 people logged in right now. Okay. We can just leave it as like one big classroom. And then if one of you is saying, hey, I need some help on the reviews, you can just simply say, hey, I'm doing the reviews project, put it in the chat. I'm doing the reviews project. Can anybody help me with step whatever? Or what do you think about this? That kind of communication. Or you can open up your mic and try and chat and just kind of do it as one big massive group. That's one option. Option two is we can do breakouts. Now, the way breakouts work is I could create 3 separate breakout rooms within Zoom, and all the people doing the airlines or the flight predictions project could be in one group, and all the fraud in another group, and so on. But what that does then is, like, when, let's say, you take off mute and start talking, you're only talking with people that are doing the same project. You can all kind of brainstorm a bit more. It's a nice collaboration option, but I've also found sometimes people just don't use it. From group to group, from class to class, I've had some classes that use that extensively, and other classes don't use it at all. And then they find it's actually kind of nicer to have everybody available to their disposal to have conversation with. But it's up to you. Any votes or suggestions one way or another? Anybody have any preferences? Just out of curiosity. I mean, we can start with just leaving it as is and then seeing if it would be beneficial, right? Yeah, one large group. So we're kind of getting different takes on that. So what I've done the last couple classes, and I felt it worked well, was just to leave it alone. You kind of leave it like this. And if we find that there's enough questions, enough discussion happening, then we could fall back to more of a breakout model. All right. Is that okay? I mean, just kind of assess it and see how it goes. And we can always pivot, you know. Good with that? Okay. Let's just do that then. Because there's some drawbacks to the breakout model, and the drawback would be like I'm not in the breakout. I would have to kind of bounce around the breakouts, kind of see how everybody's doing. So then if you want to talk to me, you would actually have to leave your breakout and grab my attention outside of the breakout. It's kind of cumbersome. So you're actually, it's almost like it's its own Zoom session. It's like you're swapping Zoom sessions. Zoom does it for you automatically, but it's cumbersome because you do have to go back and forth. So one large group does have some benefits, as long as there's not tons, if there's tons of conversation happening and it gets distracting and stuff, then we'll do breakouts. Okay. So we'll kind of play with that. Also, I'm sure you have your own tools as well. I'm guessing you probably all have like Slack or Teams or something you probably use if you want to communicate with a few people that are doing, maybe you're friends with or your coworkers with, and they're doing the same thing you're doing. Feel free to communicate however you want to communicate, right? So we'll assess. We'll kind of just see how it's going, okay? But let's check in 2 hours. We're at 1 o'clock Eastern. I'm just going to round up. Actually, we're at 2 o'clock Eastern. So that puts us at 4, okay? It's possible we might go all the way out to 4:30. If that's the case, what we'll do is we'll just kind of do the lab for the day, right? And just call it good if that happens. So we'll check in at 4 Eastern and just kind of see how you're doing. If everybody's done, then we'll pick up our next conversation. If not, we'll go out to 4:30. And then we have also some time allocated for separate study work. So at 4:30, regardless, one way or another, I'm going to go through some of the resources with you a bit more. We're going to kind of talk about the exam a bit more. Okay. So we can kind of table whatever you're working on at the time, and then you could always wrap up after that. But let's just check in at 4 o'clock. We'll see how everybody's doing, and we'll go from there. Okay. Everybody have a wonderful time. Again, don't forget, do your exercise. And then as soon as you're done with the exercise, just go straight on into your project. No waiting, and then work on your project. And when you're done with the project, you're going to get through the end of lab 2. Do not start lab 3 in that notebook. You'll see that marker where it tells you that we're not going to do any training work. So don't start that. Okay, that's for tomorrow. Okay.
Hey,
so let me know if you
Brian?
have any questions. Yeah, go ahead.
Yeah, before you go, I have a question about the student project template. One of the questions,
Okay.
the number 6, reframe the business problem as a machine learning problem. Where do I find how do I find an example of that? Like, how do I
Okay, so a
reframe
machine
that?
learning problem would be saying that it is, we're probably going to make it we're going to do labels, or we're going to do clustering, we're going to do binary classification, multi-class classification, that kind of stuff. And then basically what would be considered a success metric for the model. So in that regard, maybe we say that, like we used an example in class where it was in one of our slides where it said 75% of the time we need to be correct on forecasting on fraud, I think is what it said. I forget what example that was, but some kind of a metric of accuracy typically. Or I should use accuracy loosely because we are going to have more conversations around that. We got precision scores and all kinds of things we could go off of, but really that we're going to say, here's kind of the level of quality we expect from our model. It's not necessarily taking the business into consideration with that one, because that's a strictly scientific number. Like if our model does not perform to that, the model is not useful to us. So it's a line we're kind of drawing and saying we must achieve this level of accuracy with our model, or it's not worthwhile. So usually you're going to specify some sort of level of accuracy with the model. In other words, when you run a test data set through it, that it gets 9 out of 10 of them correct. That kind of thing. You're never going to be perfect. You can't tell the future. So how accurate does it need to be considered useful to you? And so that's kind of what that statement needs to kind of include.
Okay, yeah, I had some of that in my question 5 without the success, so I'll just pull that down to 6.
Perfect. Yeah. Awesome. Okay. Yeah. Any other questions before we set you loose? Awesome. Okay. Well, again, check in at 4 o'clock, see how everybody's doing. If at any point in time you need help, just grab my attention in chat. I'm going to be monitoring that, paying attention. I'm sitting here. I've got some other work I'm doing as well, but I'll be monitoring that chat. And if you need anything, I'm right here for you. Okay. Everybody, we'll see you back here in 2 hours. And in 2 hours, you don't have to be done. I'm just going to check in and see how you're doing. Okay. But again, rule of thumb here, just make sure you don't spend a crazy long time on any one cell. There's those cells that have a comment that says insert, put your code here, right? If you can't figure it out in a few minutes, go check your solution out and copy it over. The solution file is going to include that information for you, and you can kind of understand what they're doing that way, and it gives you the answer. So don't get stuck. I've had people that want like 4 hours on this, and we're just not going to give it to you. If you want to work on it after hours, that's perfectly fine. But at some point, we need to be progressing forward. Okay, so just find a balance point there for yourself, and move along. All right, everybody, we'll see you back here in 2 hours. Let me know if you need anything. All right. Just a quick check in here. So go ahead and use that green check if you can hear me right now and you're listening. Doesn't matter if you're done or not. Just kind of check and make sure first off that paying attention. You can hear me all right. Oh yeah, no problem. Start the share back up again. Perfect. There we go. Okay, good. So go ahead and don't worry about giving me any more feedback. I'm going to clear your feedback here. Clear all feedback. If you are done and you are ready to move forward, go ahead and check that green box again, or do some kind of signal there to let me know you are good to go. That kind of gives me an idea of how many are done and how many might need more time. So don't mark anything if you need more time. I just want to see who's done. Okay, so it looks like maybe about half. All right. So let me go ahead. One more time, I'm going to go ahead and clear all of these. So just for clarity's sake, who needs more time? Go ahead and mark that you would like more time, that you're still working, you'd like more time. This is the inverse of my previous question. Okay, so a handful of you. All right. So, and I'm sure there's probably more that didn't respond at all one way or the other, but okay, let me go ahead and clear this. So here's what we're going to do. So there's a handful of you still working. I don't really want to cut you too short. Tomorrow, you need to be able to pick up at the beginning of lab 3, which is the end of lab 2. So you have to have this done, okay? Or else you're going to set yourself back and then you'll keep falling farther and farther back. So of course you can speed it up by just using the solution content. If you need to copy and paste that stuff over, you can do that. But do try and accelerate, okay? With that said, what I think we're going to do is we will just save the model training discussion, which is what comes after this lab, for tomorrow. And we'll do checkpoints and things like that as well in the morning. But here's what we're going to do. A class runs until 5. Please don't bail early unless you absolutely have to. I know some people have like child issues. They got to pick people up and whatever. I mean, things happen. But if you got to stick around until 5, at 4:30, Greg from WebAge is going to jump on and kind of introduce himself. He's your primary manager, if you will, for the course in terms of logistics and things. If you have particular questions administratively, anything about the program in general, not just this class, but overall the much bigger program that you're being offered here, all the resources we've got, whatnot. He's just going to jump in for a couple minutes at 4:30. When he's done, we're going to go over some of the additional resources. Now there is your practice exams are now live, and I'll kind of show you that, walk you through how to get to those. I'll show you where the recordings are in the student portal and a few other things just to kind of go over before the 5 o'clock hour is up, okay? Or before the 5 o'clock hour hits us. So let's go ahead and just kind of let everybody continue to work until 1/2 That's 25 minutes from now. So at 4:30, we will draw a line in the sand, and Greg will join us. Please make sure you're ready to go at 4:30. If you still have more work to do on your lab at that time, you can resume it at 5 when we're all done and just kind of wrap it up. But I do need you to get to a point at which you are done for the day so that you're ready for tomorrow. I don't want you to start off tomorrow being behind, okay? So if that means you've got to work a little late tonight or you got to, finish it up later, you can. Your labs for this, you'll notice, different than yesterday's lab. The labs have like an 8-hour timer. So they will go later into the evening hours if you don't get it done during class. Okay. So it won't time out right away on you, but you definitely want to make sure you get that done and saved off to your local computer before that timer expires, though. Because once that timer expires, everything will be deleted and you'll lose your work. All right. Very important to understand. So 25 minutes. If you are done, which again, about half, maybe even 2/3 was already done, you get a little extra free time. Try and make sure you're keeping up on your stuff at work so it's less of a burden on you. You can also review some of the resources available to you. Maybe just kind of poke around and play around inside your lab environment if you'd like to do that as well. But we will see everybody back here regardless at 4:30 for Greg to join us, and then we're going to go over some resources for you, and we'll take that out until 5, and then we'll be done for the day. Okay, so we'll see everybody. Make sure you're back here, maybe even a couple minutes prior to 4:30, just so you're ready and we don't, miss anybody. Okay, so we'll see you back here 4:30 or even a couple minutes prior, and then we'll kind of start doing the final stuff for the day, and then we'll wrap things up. Okay, we'll see you then. All right, everybody. We're almost at time. Looks like I think Greg's joining us right now. So we got about 1 minute here, and then we'll go ahead and hand it over to Greg to kind of just chat a little bit here, and then when he's done, we'll go over some testing discussions and whatnot for the final time period until the 5 o'clock hour hits us. So let's see here. If you want to go ahead and use that green check just to let us know you can hear us okay, you're back, you're ready to go, that'd be great. You're kind of ready to go. The lab's done. You're done for now anyways with your lab. If you still got more work to do, you can do it after we're done at 5. You can go ahead and pick it up and resume however you'd like to do that. Just make sure you do get completed before we start tomorrow so that you're starting fresh and clean. Okay. All right. Looks like the majority of you are here. Greg, if you want to go ahead and take it away for a couple minutes, go for it.
Hello, folks. How's everybody? Many of you know me by email with just the communication for the class and some of the things that we're offering as part of it. I didn't want to take up a lot of your time. There was a lot of extra value adds that we included in this program to help you prepare for your certification. Exam cram sessions, which if everybody's been into the student portal, you'll see a document with dates and times for the exam cram sessions. So just take a look at that. We uploaded this morning the licensing for your practice exams for Dojo tutorials for the machine learning course. So if you haven't done that yet, you'll see a file underneath supplemental. Let me do a quick screen share if you don't mind, Ryan.
Go for it.
All
Let me stop mine here. There we go.
All right. Can you see my screen? Or not yet?
Not yet.
All right, let me try that one more time. Screen share this. Okay, so this is the, if you folks have been here at some level, I know probably just to get your link and then, information on the course materials, but underneath supplementary documents, there's accessing your practice exams. If you download that, there's actually a code that you would use with instructions on how to access that code. And Ryan, at some point during the week when he's doing his test prep sessions at the end of the day from 4:30 to 5, may walk you through the use of the Dojo tutorials practice exams. They are multi-use exams, and they're really a good tool. So during the half hour at the end of the day, he'll show you how to use it, may do a couple practice test questions, but what we want you to get out of it is how to use it yourself. So after the training is over and as you're preparing for your exam, you'll be comfortable with using the tool. The exam cram sessions are listed here. And these are 3-hour sessions where we're going to use some of the tools that we teach you within the half hour at the end of every day, the additional resources to help you prepare for your exam. And there's multiple dates and times here. We're adding one more time on February 16th at 9 to 12. So that'll be updated in the portal by tomorrow. So they are 3-hour sessions. Ryan's actually doing the ones on the 16th, and a gentleman by the name of Michael Forrester is doing the sessions on the 15th. So you can go to as many as you like, one or all 4 of them once all 4 are posted. Obviously, it depends on your workload. And then we're putting the recordings in here the morning after each day. So you'll see that already the session from yesterday's in here, and we'll add those as we go. So anyway, I just wanted to make sure that people were familiar with this and kind of knew what to find there. So does anybody have any questions I can answer for them before you get back to your last half hour of test prep starting for the day? And feel free by chat. Let me just put my email in the chat. I think a lot of you have it already, and it's obviously listed in the portal as well. But if you do have anything, don't hesitate to reach out to me, and I'd be more than happy to help answer any questions you may have. I'll give it a minute, but if there's silence, then I'm assuming that people have found their portal and kind of know how to navigate it.
Hi, Greg. I have a question as it pertains to the wiki labs. right now when I go there, I see my training and I can go in there and do my labs. After this training, will I be able to go back and do other trainings with credits, because I don't see any credits under my name?
So are you talking about the supplemental labs or the quick labs associated with the actual course?
The supplementary labs after this course, sorry.
Yeah, so first off, with the quick labs, and Ryan might have mentioned this already, you have access to the labs from this course for 3 months after the last date, but you can only do each lab 3 times. So even with a 3-month time limit, once you do a lab 3 times, that's it, you can't do it again. As far as the supplemental labs, there really aren't any supplemental labs that go along with this course. In the study guide that we included under the machine learning certification study guide, there are some links of video content, on-demand content that will help you prepare for the exam and just knowledge of the area in general. But like I said, there's really, and you can confirm this with me, Ryan, but I don't think there's really any supplemental quick labs that go with this particular course.
Well, not necessarily with this course, but in the catalog, I would never be able to search anything here in the catalog on quick labs through Booz.
You should. So Booz Allen as a company, we have a bucket of credits in the quick labs that as long as you log in with your last name _ first name at bh.com, there are credits available to employees to do extra labs, even if it's not related to your particular class.
Yeah.
And last we checked, there was about 350 credits in there, but we replenish them all the time. So if you're logging in and see it's at 0 credits, that means we need to put more credits in the bucket. Is that what you're seeing?
Yeah, no, I'm not even seeing anything. I just see the settings. So I'm wondering if I'm just not in the right place, or I'm just not understanding where to go. Yeah, I don't see any credits at all. And when I go to the catalog to do any search, it says 0 results.
Ryan, do you know, I'm not great at navigating that site. Do you know exactly where to go to find those quick labs and how, I know you've taught classes for Booz Allen before and what we have set up for them. Do you know how to help these?
I don't remember for Booz Allen specifically, but I think they have their own. I mean, it's not going to be under the WebAge.QuickLabs, will it?
No.
Oh, that's the issue. The WebAge.
Yeah.
Okay.
It's
Correct.
not under WebAge. That's
the
okay,
difference.
Yeah.
That's the difference.
All right.
Yeah, the WebAge is associated with the official labs that are part of this course.
Exactly.
The other quick labs are just the kind of labs outside of it. So no, if you go under the other one and log in with your Booz Allen account, you'll find available credits to you.
Okay.
Yeah, there's basically 2 models with quick labs. There's like public labs, if you will, and then there's private labs that are for the class. And so when you go to like the partner.quicklabs.com, so like in this case, webage.quicklabs.com, you're only going to see the labs associated with the class. No public labs are going to be shown in there. But when you go to, I think Genevieve is right. I think it's under either Amazon.QuickLabs or maybe AWS or just maybe even WW. I don't really remember. So you might have a link for that somewhere else. But it would be, you just go to regular Quick Labs, you'll see all of those public labs, and there's, I don't know, 100 some odd AWS labs in there, I believe. And then you just use your credits at that point.
Yeah, I already went there and I had the credits and stuff, and then I clicked here and it was like nothing. So it's like
Perfect.
a little, but thank you for that clarification.
Absolutely. Yeah, that's great. So as long as you saw some credits there, then you should be good.
Yeah. And I just saw the comment about the voucher code. It should be for machine learning. So if you're seeing an option for the developer, don't redeem that code. Let me go check to make sure the right code was loaded. We do have developer classes running. Okay, it works for machine learning. Okay. All right. Yeah, and so if you found the code within the portal under accessing your practice exams, yeah, BAHMLS. So that should be the right one. So it looks like we've got the right one here for you folks. But if anybody else is having a problem with it, just you can email me directly. I don't want to take up too much more of your study prep time, but you have my email. If you do need anything, certainly let me know. And I'm pretty much, if I'm awake, I'm online, so I'll respond pretty quickly. All right. Anything else before I jump off? Okay.
So Greg, yeah, it looks like just that link might be
Oh.
taking him to the wrong spot, but it looks like it's
Yeah. Okay.
that
Okay.
link, probably copy and paste snafu, but
Can you copy the right link in there? We'll have to fix that.
yeah, well,
That's the problem.
yeah, we'll figure it out. That should be an easy one to fix, I'm hoping.
Okay. Yeah, I see what happened. Okay. Yeah, we made multiple copies of this for various classes, and it looks like we didn't update the link. But I will fix it and re-upload it just so there's not confusion, because we have 65 people attending 3 different machine learning classes next week. So I'm glad you guys saw that for me. Sorry about that confusion. A lot of moving parts here, but anyway, thank you so much. And like I said, if you need anything, just let me know.
Well, Greg, appreciate it.
Yeah, bye.
All right, so let's, on that note, let's go ahead and actually jump in to that student portal, and we'll kind of check out Tutorials Dojo, and kind of recover that just a little bit more in detail. I just want to make sure everybody's clear on where they need to go for their resources. I think that is going to be critical here for you, and we can kind of go through some of this stuff together. All right. So let's make sure I got the right screen shared here. Looks like we should be okay. Sorry, just one second. Let me try that again. Okay. So so here's, this is your portal, right? And then the recording from yesterday is right here. And I think Greg already pointed this out, but you can click into it and you'll basically be able to play it inside the browser. I don't believe, I don't know if you can download it. I think it just has to open up in the browser. Yeah. So it's not really meant to actually like download a video file. And it's just, that's for like copyright issues and some other things around the materials and things like that. Make sure you shouldn't be able to just share a MP4 out there with all your friends and whatnot, right? So it's just going to be inside of there. The machine learning certification study guide. So Greg touched on this one. I wanted to show it to you real quick, kind of go over this. So he didn't go over this in the last couple of minutes. He mentioned it, but we didn't go into it. So this is the study guide that comes up. Now, this is not the one produced by AWS. Now, we talked about the one yesterday from AWS, which is the exam guide that AWS publishes to kind of show you all the domains and kind of some of the subtopics and things that you need to cover. So that's a good one for you to have as well, directly from AWS. Under the certifications page for AWS, you'll find it in there. You find the ML certification, specialty certification, and then you'll find the exam guide in there. This is produced by WebAge, and it's a very helpful kind of guideline and links and whatnot to supplemental study materials. Okay. So you'll notice here, I mentioned this one yesterday, but the machine learning pipeline course, this course that we're in this week, covers maybe 65 to 70% of the materials for the exam, but not 100. There's actually a substantial gap, and you can fill in a little bit of that gap by taking even more classes, but that's not what Booz Allen's doing here. Like I said, there is a deep learning class. There's a SageMaker, one-day SageMaker class, a one-day deep learning class, and some of these things you could do to kind of pile it on, but a lot of duplication of content in those classes. So you might take a one-day deep learning, or let's say a one-day SageMaker class. 2/3 of what we teach in this class is covered in there, but there is just a little bit that's not. But that's not stuff you really need a class for. If you can just kind of go in and experiment and do some labs and stuff, you'll kind of discover those differences or the stuff that's not covered in this class. The deep learning, right? There is a one-day deep learning class out there, but there's a lot of stuff you can kind of do some reading on and some experimentation on your own and whatnot, and some labs as well to kind of cover a lot of the topic. But these links here, there's some digital trainings. These digital trainings are like self-paced kind of deals, right? So as an example here, here's a developing machine learning applications, getting started with Julia and AWS SageMaker. Let's just pick one of these here. So a serverless data analytics pipeline. There's a white paper here for that. You can check this out. I mean, a lot of the white papers are pretty easy reads. I'd recommend you go skim, check out some of these white papers, help you kind of learn some of these things, read through that. Let's check out the one of the digital trainings though, just to kind of show you what those look like here. So I'm just going to choose one.
Hey, Ryan, quick question.
Yeah, go for it.
So for the white papers, because I'm like looking one right now at like building a secure enterprise machine learning platform on AWS. How like detailed should we get into in the white papers? Like I get like the classes, it's easier to take notes like with the trainings and like,
yeah,
okay, like, but like a lot of this is like a lot of stuff and it's I feel like can be pretty easy to get bogged down.
Yes.
How would you recommend getting the most out of these white papers without spending, hours and hours of time that might not be, as important on these?
That's a wonderful question, because you absolutely could get bogged down. There's too many resources can be a problem, right? And how deep into this web do we go? Because there is an endless web here. I mean, there is no end to it. So just keep in mind some of the stuff I talked about yesterday. It's kind of why I brought some of that up as far as kind of that bloom level stuff we were kind of going into a little bit. I kind of went extraneous outside of the materials for that reason, because just to kind of keep in mind, it's about being able to understand the topics really and understand the technologies. So it's those are more big picture. So the white papers do go into great depth. You don't need to memorize that depth in any way. Really just kind of focusing on kind of the level of what this exam is about, and just to kind of kind of throw that one on the screen here, just to kind of recap on that one. Open image in new tab. So there was this image that I pulled up yesterday. I think there was a better quality image I found, but the basic idea here is the specialty exams kind of fall into this evaluate, analyze, apply, not so much create. It's not all the way up to there as much. It's really kind of hovers in this evaluate, analyze, apply kind of realm. And kind of keeping that in mind is really important as you're kind of going through some of these white papers, because you don't need to memorize a whole bunch of facts. Now I know it's built on top of remember and understand and apply. Those all kind of build on top of each other, but the exam is really about being able to understand the concepts and really be able to kind of apply some of these concepts to the bigger picture. So I would look at most of those white papers more from a conceptual understanding, how the pieces work together, how SageMaker works. Again, the how it works, less about the intricate details, about the exact settings and how you actually go about building it out from scratch, and all the settings and all the stuff. It's more about the bigger picture. Okay. And so, Desiree also kind of on that same note, this study guide was put together for this exam. Okay. So all of these are relevant to this exam. I just want to point that out. Nothing in here is not relevant. This was crafted specifically for this exam. The reason the relevant exam area is things like analytics comes into the picture of machine learning still, and natural language processing. The concepts of it may come into play. You're going to have a light amount of questions on NLP and computer vision, but they could creep into the testing. There could be a couple of questions. So it's not core to machine learning, but these are definitely machine learning topics still. And again, keeping in mind that it's not just the machine learning pipeline as the exam, it's machine learning in general, which can include all sorts of subtopics, right? So that's why we've included some of these other topics, because these topics are not covered in this class. And because of that, there's gaps, and you may come across a little bit of NLP or computer vision kind of questions. But again, it's more conceptual. So just kind of take these with some kind of bite-sized knowledge where you're really kind of looking at the bigger picture of how this works. If somebody mentions NLP to you, can you describe what it is, how it works, how you would go about performing NLP in AWS? Less about the little intricate details. Okay, more about the bigger picture of connecting the dots. bigger picture of understanding, the technologies that exist and how we would go about using those technologies. That is the focus here. Okay, very important. And then, the practice exam, Chris brings up a great point there too. The practice exam would be a really good way to help identify your weak points, right? Those practice exams that's a key reason to use them. I do want to point out something about practice exams in general. I don't care who or what you use for practice exams. I mean, we provide you some stuff here through WebAge to be able to really kind of help you out there. The practice exams that are provided through Tutorials Dojo, which we're going to show you here in a second, are above and beyond what AWS actually requires. And that's good. They're a little bit more difficult. More difficult is a good thing because it, prepares you so that when you go to the exam, you're able to confidently pass it, right? As opposed to just kind of being on that edge. You always want to overtrain just, a little bit, but just to an extent, right? So the practice exams are a little bit more than the AWS exam by design. But they are kind of a good way to understand where some of your weak points are, and then you can kind of do some self-study to kind of catch up on some of those weak points, right? And so they'll help you really kind of hone in on those spots. I like that approach. One other thing I do want to point out, though, like I said, whoever you use, any practice exam you might ever see, whether it be through Tutorials Dojo, through this program, or something else, AWS exams, specifically the way AWS does this, they're very, very secretive. Okay, so let me just kind of explain the exam process just a little bit here for you as far as the big picture. Like as a trainer, I am actually not allowed to work with the exam teams at all over at AWS. I've been offered opportunities to join that team, but I would have to give up my training. I would not have the certification anymore. I would not be allowed to train classes. I would not be allowed to see the training materials without actually just attending a class as a student, right? As far as testing goes, I can't take the tests more often than anybody else. So your exposure to the test can be the same as mine in terms of I have to recertify every 3 years. I can't take it earlier than that. You go to like Microsoft as an example, they've been training and testing for decades. And one thing that they do is they allow their trainers to take the exams unlimited amounts of times. They get free test vouchers, and they can just take them every week if they wanted to. And the point is that they could test to they could teach to the test, right? Amazon does it differently in that there is strict NDAs, and which a lot of them have. But then to couple with that, there's really no way to take the test a whole bunch of times. So when you see providers do sample exams, they can get close, but they are never going to be an exact representation of a true AWS exam because of NDA issues, because of that issue of, you're not allowed to see it over and over and over again. So the less information leaks in that regard. There's a lot of factors there. So my point, what I'm getting at is it's a great assessment tool to kind of see how you're doing. Just do understand that the questions may not be a perfect representation of the way AWS is going to present them. Now, obviously, they're not going to be the same questions. I can get that, but even just the representation of the questions may be a bit different. The question structures, the rules around how they make their questions. AWS has some very strict ways that they build their questions, like their formulas to build out a question and answer pool and whatnot. Whereas Tutorials Dojo may not have those same requirements, and theirs are going to vary. So it's a good way to assess. Fantastic. And so like I said, I think the questions are actually a bit harder than you'll find on the AWS exam, but that's a good thing. It'll get you just a little bit past where you need to be to pass the exam smoothly, right? And make sure you got all you need. But when you do read these other white papers, and this kind of goes with all AWS certifications, like I said, be careful not to get hooked up when you're kind of stuck in the weeds of the details. Always kind of back up and get an idea of the big picture of what it's trying to illustrate. Excuse me, my apologies. And try and focus on the messaging, the big picture, the hows and the whys, not so much the intricate details. So if you do that, you'll be fine. then you can throw a lot of white papers at you. You can read them quickly. You don't need to pause and really, take notes about every little value and every little specific. That's not going to do you any good. Okay, that's just going to bombard you and really kind of get you stuck in the swamp of information, right? So that's kind of the direction there. Keep in mind also when you do labs. So I want to highlight something about the labs for just a second as well. So as we do these projects, as we do this work in this class that we're doing this week, it's also really easy to overthink the labs. Okay. And here's what I mean by that. If your focus is to pass this exam, which it should be, I mean, you want to learn all of this just in general, right? But you also want to pass the exam. Don't think that we're doing all these labs for you to memorize SageMaker calls and things like that. Okay. Just like that Bloom level I was showing you, the labs are not about memorizing anything. Okay. The labs are about connecting the dots for you mentally. Okay. So when you go through the lab, you understand what's happening when you go do a training activity, and you understand how this kind of interacts, right? And you have a good, clean understanding of the bigger picture. But don't do the labs and think you have to memorize every thing we're doing in here, every command, and really down to that level. So do the labs and do them even multiple times. Do different projects. Try and go through all 3 projects if you can on your own time, right? So you can certainly do that. But again, just don't get wrapped up too much on the individual calls. Just understand the process, understand the activities that have to take place. That's the critical part. And understanding how to read, whether or how to know if a model is successful, how to monitor it, how to deploy it, right? And again, it's that how and why and kind of that big picture, not so much the individual commands. I mean, there's a couple small things you may want to understand as far as calls go, like the .fit. What is that doing? You'll see as we go through some of these things in a couple of days. The next couple of days, you'll kind of see the key things that we tend to do. But beyond that, all the little intricate stuff we don't really need to get into. You're not going to have a whole bunch of API call questions. You just may need to know basically what happens when you call the fit command, or really kind of there may be architectural questions around how SageMaker actually does what it does with the whole Docker container concept and storage and understanding how you might handle the different storage options or what options might exist, that kind of stuff. It's about kind of being able to understand the steps involved in being able to get this stuff done and the requirements that you might have, but not so much, down to that individual call level. Okay. All right. Any other particular questions? And we can check out a couple other things here, but all right. So if we real quick check out this digital content here, you'll notice I just clicked on this data analytics fundamentals. Analytics, of course, is a broad topic, not just machine learning only, but it might help you kind of connect more dots. So again, looking at it from a big picture perspective, this one is 3.5 hours worth of extra free self-paced content if you want to go through this. These digital self-paced courses are fantastic by Amazon. There's a lot of topics that you can learn for free, and they'll just make you stronger and better in AWS and on a lot of these different topics. So you just hit enroll, and you would be able to go through the content. Again, it's free, so all these different free ones. Why wouldn't you make the time to do that? It's just going to make it better, right? But I just wanted to point out that's one of the digital. That's what the digital ones look like. So if I go back to, so how do we get to that page? So it was a link. If I can pull it up, gosh, again. Okay, where'd it go? Oh, I guess I went off the screen with that. Okay, so let me maximize this. So this page, right, which is found, just to clarify, that was found in the student portal. So can I show you how you get there? In the student portal, we have this certification study guide. Okay, that is the study guide made by WebAge. Okay, and that's this one. In here, that link I took you to was the digital training link here. Okay, so that was this one, the data analytics fundamentals, and that's a 3.5 hour training for free. Okay, so that's this category right here. So it's an analytics category, but of course, machine learning is analytics, right? It at least comes underneath kind of that heading. It's a very special kind of focus, but so the point is there is you may not. One thing I want you to understand is with these AWS specialty certifications, you have the content of the certification itself, but there's a lot of fundamental knowledge that is also built at the lower quote unquote levels. So there's other classes that may feed into it that aren't even machine learning at all related, right? Architectural standards that would be found in like the architecture classes. Stuff that is found in some of the kind of quote unquote lower level classes that you would build on that knowledge, right? So that's the other thing too, is I know some of you are really pretty new to AWS and you've kind of skipped that to some degree, right? So I want to just real quick just show you this. Once again, AWS certifications. And if you come over here, and then we'll wrap this up for the day. But if we come over here to AWS certifications, remember all the different certification options that are available to us. We're focusing on this machine learning specialty. Well, these are specialty certifications. Technically speaking, they're designed to follow these associate certifications. Okay. It used to be years ago, you had to actually have an associate cert to even take a specialty cert. They took that requirement away, but taking the requirement away doesn't mean that the knowledge isn't needed. It just means that they don't need you to go take one cert just so you can take another. Okay. So Amazon took that requirement away, but the knowledge requirement still kind of is there. So the content for machine learning by itself may hinge on some knowledge that actually comes from these other things, architectural principles, operations kind of principles, something like that. This is where things get a little bit interesting if you're jumping straight to the machine learning specialty, because it is a specialty certification, which is difficult, right? It hinges, it's like assuming you have kind of a foundation set up and then you added some sort of specialty to it. Right. And if you don't have another cert, it's okay. Just you have to understand that there's going to be a little bit more you'll have to kind of backfill on your knowledge. And so that's why we set up, that's why this is here. Okay. Now there's even some stuff that's kind of, I think, even somewhat missing out of here that is potentially some key things that might be helpful, just general AWS knowledge. It'll help you on all AWS certifications. And one specifically that I would recommend you get familiar with is the AWS well-architected framework. Okay, if you're not familiar with this, go get familiar with this right away. This is not in that spreadsheet, so this is totally separate. This is just me bringing this up to you. So I'm going to put this in the chat so you can grab this link and make a note of it for yourself. But come here and study these pillars, these well-architected pillars. Now, you're not going to be tested on these, okay? Because that is really more for like your architecture certifications, kind of this architecture track, okay? But is it possible that there are best practices in here that would apply to building a machine learning pipeline? You see where I'm going with that? Is that the well-architected framework is kind of assuming anything you build in AWS, DevOps pipelines, machine learning pipelines, big data pipelines, just some regular website, whatever it might be, all of those things, there is a base kind of set of principles that Amazon recommends we build off of. And that is the well-architected framework. So don't study it with the idea that you're going to have to memorize anything. Just take the concepts away from it so that you can apply those concepts to your thought process when you're taking the machine learning exam. Okay. So the kind of less fact-based kind of questions, the stuff where it's understand, apply, evaluate, those kind of things, is expecting you to kind of have some fundamental knowledge about the approach that Amazon wants from you. And so that well-architected framework is a starting point for all AWS exams. So I like to throw this one out at anybody. If you're not familiar with this, this is the place to start. Now, don't worry about the tool and all of that. Really just focus on the framework, which is really a white paper. There's these pillars right here, and then those pillars are accompanied by white papers. So like you could come in here. There's the operational excellence pillar, security pillar, reliability pillar, performance, cost, and sustainability. And each one of these you can open up in an HTML format or a Kindle format and read basically the white paper for that, right? For that one. And then interestingly enough, one final thing, Amazon actually provides their own labs. So if you're looking for kind of quote unquote supplemental labs, as was brought up, there really aren't any labs specifically for ML outside of the stuff in Quick Labs that we've provided you. But you can come here and maybe you want to learn just a little bit more about AWS in general. Now, don't get too inundated with this. I got to kind of caution you. Again, there's unlimited things you could do. But if you're still kind of like not quite sure about something in AWS and you just kind of want to get that understanding, these are all things you can do in your own AWS accounts. And so you can go spin up your own personal AWS account and do some labs around reliability, let's say, building reliable solutions, right? And so you come into the reliability here and look at all these different labs. These are all things you can do in your own accounts and you could build out. And so like, I'll just kind of show you one of these real quick. You come in here and this is a lab where here's some goals about what you're going to do in the lab. There's the prerequisite is really that you just need your own AWS account. And then it'll walk you through the steps. So the first section here, deploying an infrastructure and application, it'll walk you through all the steps. Click here, select that, type this, download this file and upload it, all that kind of stuff, and kind of walk you through building that whole solution. Again, just remind you where that was found is I just clicked on labs underneath the operational pillar, but in all reality, once you're in there, this is all hinging off of this site called wellarchitectedlabs.com. I'll give you the link to that. And those are all in alignment with the AWS well-architected pillars, which again, like I said, all things AWS are hinging off of that. So if you want to augment and do more work and play around with more technologies, that's a great place to go. Just be careful because again, like I said, there's unlimited amounts of stuff in here practically. You could spend 40, 50, 60 hours doing this stuff and still not be prepared for the exam. Okay. So really kind of hone in on areas that maybe you think would be helpful for, with the machine learning idea in mind. But as you're building out resources, building out storage, things like that, talking about resiliency needs and things like that of your ML pipeline, some of that stuff may come into play. So just, I would say start high level though, understand the pillars and understand the concepts with that and kind of build all your knowledge on top of that. Okay. And then if you want to really get any hands-on, you could over here in these labs. Okay. So that's enough. Plenty. We're long here. We're 7 minutes past. My apologies. I just wanted to kind of wrap up that discussion and kind of make sure you got plenty of resources available to you. And you also don't overstudy. I don't want you thinking you got to read these white papers, memorize everything in each one. Okay. That's not at all the goal. It's the big picture applied in each one of them. Okay. So this right here is a very helpful study guide to kind of give you extra additional resources outside of this class. Okay. All right. We'll see you tomorrow. Hopefully everybody downloaded their project work from today. If you haven't ended your lab yet and you haven't done that yet, make sure you get it done. Wrap up your lab and we'll see you tomorrow. You're going to need that file tomorrow. Okay. Everybody have a wonderful night. It's been a pleasure. Thanks for hanging with me a few minutes late. I know some people have other commitments you got to get to as well. So I'll try not to normally run late, but it just wanted to get that last stuff out of there to you. So we'll see you in the morning. Take care. Have a great night. Wonderful evening. Okay. Take care.